traditions in universities that are able to create superior people to build the city and the country.
Welcome to the Faculty of Engineering, Universitas 11 Maret Surakarta, as known as UNS.
Home to thousands of the best sons and doctors from all over Indonesia to work to develop science and technology for the glory of the nation. Founded at the same time as the establishment of UNS in 1976, the Faculty of Engineering UNS provides industry-oriented tertiary education consisting of bachelor, master, and doctoral levels. Jakarta, a city in the middle of the island of Java, which is famous for its rich culture and local wisdom, is currently experiencing an increasing rapid increase in development over time. Sustainable development and full of innovation are in line with the growth and development of scientific traditions in universities that are able to create superior people to build the city and the country.
Welcome to the Faculty of Engineering, Universitas 11 Maret Surakarta, as known as UNS.
Home to thousands of the best sons and doctors from all over Indonesia to work to develop science and technology for the glory of the nation. Founded at the same time as the establishment of UNS in 1976, the Faculty of Engineering UNS provides industry-oriented tertiary education consisting of bachelor, master, and doctoral levels. Faculty of Engineering UNS now has 15 programs, consisting of 7 bachelor programs, 5 master programs, 2 doctoral programs, and 1 professional engineer program. These programs have been accredited by the National Accreditation Board for Higher Education. With a qualification of about 200 academic staff, more than 11,000 people have been educated and trained into educational scholars and mid-level expert engineers who have noble character. Whereas the bachelor programs in civil engineering and mechanical engineering has been certified by the Asian University Network Quality Assurance or AUNQA in 2018. And industrial engineering has been internationally accredited by the Indonesian Accreditation Board for Engineering Education or IABEE in 2018.
Our mission is to make the Faculty of Engineering Universitas 11 Maret a campus that excel in the field of engineering internationally, based on the noble culture and oriented to the development of society.
with a vision of becoming a superior institution of higher education at the international level in the field of engineering with the principle of national cultural values.
The Faculty of Engineering UNS
Has a mission to organize teaching education in engineering by always developing expert teaching staff and stimulating student independence in learning, organizing research that produces new discoveries, and community service oriented toward community empowerment in the field of engineering. In line with the vision of becoming a leading toward institution at the international level,
the Faculty of Engineering UNS fosters good relations with various foreign universities
by being registered in the accreditation form with 18 universities. Global Insight is always introduced to entire academic activities through various programs such as inbound and outbound exchange students, short-term laboratory programs to create output that
Ladies and gentlemen, the opening ceremony is going to start in approximately 10 minutes. Please be seated and check your connection and enjoy the opening sound and music. We will start in approximately 10 minutes. Again, ladies and gentlemen, the opening ceremony is going to start in approximately 10 minutes. Please be seated, check your connection, and enjoy the opening sound. Okay, thank you. Tunggu sutradara ini. Good morning, ladies and gentlemen. First of all, my name is Aditya Rio Prabowo from Department of Mechanical Engineering. I was assigned as Master of Ceremony for this conference. On behalf of the committee, I'm delighted to welcome you to the 6th International E-Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, Icimece 2020 in Faculty of Engineering, Universitas 11 Maret, Surakarta, Indonesia. The conference theme is towards the development of intelligent green technology to contribute high energy efficiency with low environmental impact. The conference will address the practical engineering application, it as mechanical, electrical, industrial, and chemical engineering. This conference provides opportunities for the delegates to exchange new ideas face-to-face to bring together leading academic scientists, researchers, and research scholars to exchange and share their experiences and research results on all aspects of engineering, science, and technology. This year, Icimece collaborates with European Structural Integrity Society and Elsevier BV to arrange a special symposium in field of material and structural integrity. Moreover, we also collaborate with one of big event held by Pembangkit Jawa Bali Company called PGB Connect. It's an honor to me to introduce and welcome the guests at our home. It has executive board members, Universitas 11 Maret, Dean and Vice Deans, Faculty of Engineering, Head of Department, Faculty of Engineering, and also we welcome all the presenters and participants of Icimece 2020. For a brief moment, we would like to invite you to listen Indonesian anthem, Indonesia Raya. May all participants mute the Zoom microphone.
Jadi
Thank you. Ladies and gentlemen, we are now going to listen to the welcome speech delivered by the Dean of Faculty of Engineering, Universitas 11 Maret. Ladies and gentlemen, please welcome Dr. Engineer Solihin Asad.
Bismillahirrahmanirrahim. The Honorable of Keynote Speakers, Excellency, colleagues, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Thank you all for joining this virtual meeting of International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, or Icimece 2020. As a Dean of Faculty of Engineering, Universitas 11 Maret, it is a great honor to welcome you in this 6th Icimece 2020. As someone say that the show must go on. This global surreal situation by COVID-19 pandemic has changed Icimece 2020 to be virtual conference. However, we have promised that this condition will not reduce our goal, making this conference to be the forum to share and discuss the ideas and research results on engineering, science, and technology. I especially thank to the keynote speaker, participants, sponsors, and partners for their contribution, and all committees for their great effort to organize this conference. Ladies and gentlemen, this conference was formerly known as Icimece, which is first held in November 2015. This is a series of annual conference which is usually held in Surakarta or Solo City in Indonesia. The theme of Icimece 2020 is towards the development of intelligent green technology to contribute high energy efficiency with low environmental impact. The reason why we choose this theme is because, firstly, global energy demand is expected to increase by 60% by 2030. Secondly, the price of oil and gas is rising, in which this has enforced us to find more reliable alternative energy. Thirdly, our climate is changing, and this is not only due to the energy sources we use today, but also the material we use in our daily life, which is not environmentally friendly, such as plastic. Ladies and gentlemen, in terms of Icimece 2020 data, we have received more than 270 papers in the first stage. And after a true review, there are 97 papers accepted. The papers are coming from various countries, including United States, the Netherlands, Estonia, China, Taiwan, South Korea, Japan, Vietnam, Malaysia, and Indonesia. All accepted papers will be published in reputable proceeding series, which are IOP and Procedure in Structural Integrity, and special issue of reputable journal, which are Evergreen and Open Engineering. These papers are also presented virtually and published through Icimece 2020 website channel. Due to huge number of papers presented and significant number of international presenters, I wish this conference can trigger the collaboration among the researchers and scientists, which can bring solution for global problem in energy and environmental impact, linear to the vision of the Icimece 2020. Currently, we realize that international engagement and cooperation is very important in solving the global problem that we are facing. And the Icimece 2020 is one event that our institution, Universitas 11 Maret or UNS, may contribute on it. By inviting international researchers and scientists, we want to prove that UNS is one of excellent universities in Indonesia that can work together and compete in the international arena. Finally, with Bismillahirrahmanirrahim, I declare the Icimece 2020 is officially open. I wish you a successful and enlightening conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Engineer Salihin Asad. Now we take a short break to wait the first keynote to join us in this forum. Participants are requested to stay in the forum. We are now continuing our meeting to the next agenda. That is to hear the first keynote speech, which will be delivered by Professor Ilhwan Oh from Kumoh National University, Kumoh National Institute of Technology, South Korea. The keynote speech will be moderated by Professor Agus Purwanto from Department of Chemical Engineering, Universitas 11 Maret. To Professor Agus Purwanto, time is yours.
Okay, thank you very much, Mr. Adit. The honorable speaker, distinguished guys, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. Welcome to this prestigious virtual meeting of the 6th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering, Icimece 2020, held by Faculty of Engineering, Universitas 11 Maret, Indonesia. My name is Agus Purwanto. I am a faculty member at Chemical Engineering Department, Universitas 11 Maret, and I will be your guide in this first keynote presentation. In this occasion, we shall have outstanding presentation from our prominent presenter, whom I believe shall enrich our insight and knowledge regarding engineering aspect. Before the presentation begin, allow me to introduce the first keynote speaker. Our first keynote speaker is Prof. Ilhwan Oh. Good morning, Prof. He is an associate professor at Department of Applied Chemistry, Kumoh National Institute of Technology, Gumi, South Korea. From this slide, we know that he have published more than 37 peer-reviewed journal with the total citation more than 3,600. And all his publications are in highly reputed journal with the scope of photoelectrochemical research. So in this great opportunity, he will share his valuable knowledge on the photoelectrochemical aspect with us. Without further ado, I would like to welcome our presenter with the presentation entitled Integrated Photoelectrolysis of water implemented on organic metal halide perovskite photoelectrode. Ladies and gentlemen, please welcome Prof. Ilhwan Oh. Prof. Ilhwan Oh, the presentation time is 40 minutes and you will have 30 minutes for the talk and the 10 minutes for question and answer. Okay, I think we can begin the presentation and the floor is yours. Okay.
Okay, thank you, Professor Purwanto, for kind introduction. And can everyone hear me?
Yes, no
Okay.
problem.
Good morning, everyone, and I'd like to thank engineering faculty UNS for inviting me for the keynote session, and I really wanted to visit Indonesia this season and have a good time and have a friendship with people in UNS, but unfortunately, due to the COVID situation, I'm sorry that we couldn't have the opportunity, but hopefully next year, when things get better, I hope to have a good opportunity to communicate and share. Let me share my slide. Okay, I believe everyone can see my slides.
Yes, no problem.
Okay.
Okay.
Okay, thank you for this opportunity. I'm Ilhwan Oh from Kumo National Institute of Technology, and today I'd like to talk about integrated photoelectrolysis water based on so-called perovskite solar cells. So, brief introduction. for the renewable energy and solar and perovskite. So it's all about climate change and sustainability. Now it is well established that there is a strong correlationship between the Earth temperature and the CO2 level. So as the world countries have made promise, we should keep the temperature increase within 2 degrees C, okay? And by reducing carbon emission. And of course, that's possible through the development and implementation of renewable energy technologies such as solar and wind. And hydrogen economy will play a key role in the development of renewable energy. So here I show a brief cartoon which briefly describes the hydrogen energy. So basically you use a renewable energy such as solar and wind and generate electricity. And from that electricity, you hydrolyze water to produce hydrogen. So here, hydrogen plays a role as energy carrier. And you store that hydrogen in a suitable container. And later, you use it to drive your car and to generate electricity for your homes, things like that. So about 10 years ago, a lot of people were skeptical about this hydrogen economy because the hydrogen from water electrolysis is too expensive and the infrastructure is too scarce, things like that. So, however, these days, many people, I think it is majority of the scientists, engineers now begin to believe that this is the future, the hydrogen economy. The main reason is the key factor is that now the renewable energy has replaced the conventional energy in a substantial amount. And the thing is that there's a mismatch between the renewable energy, electricity, and the actual consumption. So for example, during the nighttime, the wind turbine is rotating and generating electricity. However, the people are not using electricity as much. So there's surplus energy from renewable energies always. So you can use that surplus energy to generate hydrogen. And that hydrogen is very cheap. So suddenly, as the renewable energy advances, the hydrogen economy begins to make sense. So the picture is that in the future, like 5-10 years from now, there will be a dual mechanism for the transportation. So of course, the electric car will be used widely as a like everyday drive. However, for the trucks and buses, there's good chance that the hydrogen-based and the machines like a hydrogen fuel cell car will dominate that market. So that's the basic idea. And for more information about the hydrogen, actually there are 3 different colors of hydrogen: the green, gray, blue. And the green hydrogen is the ultimate goal the green hydrogen is the one produced totally from renewable energy and electrolysis. So it is a zero carbon emission, and when you produce it from the excess electricity from renewable energy, it is very low cost. Okay, so it is a ultimate the hydrogen you want to produce. However, in the meantime, you are generating hydrogen from fuel reforming, and you generate the carbon dioxide and you capture it through the CCS technology. So that's called that's carbon neutral. So that can be a technology you can use for the interim time. For the solar water splitting, there are 3 configurations basically, which has been developed for the last decades. The PV electrolyzer, integrated photoelectrolysis, and mixed colloid. And the PV electrolyzer configuration is the one that's been, mature. And the solar cell is mature, electrolyzer is a mature technology. So you can just combine it and make the system. And I'm quite sure this will be the technology that will be implemented in practical implementation. And however, in academia and for the future technology, people have been focusing on so-called integrated photoelectrochemistry, where you basically immerse your solar cell in the electrolytes so that you can save space, and also we hope that we can utilize the excess heat from the solar cell to speed up the water electrolysis reaction. And last one is mixed colloid, where you basically disperse semiconductor nanoparticles in the electrolyte and generate hydrogen and oxygen at the same time. This is very cheap. However, you generate a mixed gas of hydrogen and oxygen, which is explosive. So it has its own problem. So today my research has been focused on the second configuration, integrated photoelectrolysis, and more on solar energy. And like 10 years ago, a lot of people thought that solar is too expensive. It was about 5 to 10 times more expensive than conventional electricity. So a lot of people thought that it doesn't make sense to implement large-scale solar generation. However, people have been working hard to reduce the cost. So now, in a lot of areas of the world, the so-called grid parity has reached. So basically, the electricity from the solar is same or less expensive than the conventional electricity. But still, the efforts are ongoing to reduce the solar cost. And there are 2 ways that you can reduce the cost of the solar energy. You can reduce the cost by increasing the efficiency, and you can also reduce the cost by reducing the module cost. So from the rough calculation, if you increase the efficiency by 2 times, you basically decrease the cost of the system by 20%. And if you reduce the module cost by half, and the energy cost will be reduced by 25%. So both efficiency and module costs are important to reduce the solar cost. So in solar technology, let me look at the time so that I can see if I'm in time. The silicon is, of course, the dominating technology. But 90% of the current solar cells are silicon-based, and has high efficiency, 25%, and module cost is reasonable. So I'm quite sure still in near future, the silicon will be the dominating technology for the solar cell. However, there are developing technologies like second generation solar cells, CIGS, CATL, things like that, and they claim that they are cheaper. However, they are not as penetrating as expected. And there are third generation solar cells, and among them, the perovskite is getting most attention these days. And that's because the performance of the perovskite material has soared in very short time. So in about 10 years, the efficiency has increased to about 25%, which is amazing. That in a very short period of time, the efficiency has increased to such a high level. So that's the reason why a lot of researchers around the world are enthusiastic about this technology. And the improvement mainly came from by developing a way of producing high quality film deposition, such as solvent engineering and composition engineering, so that you can optimize the perovskite film. And basically it has a perovskite structure, ABX3, and it has a strong absorption due to the direct band gap. So that's the reason why you can have a very thin perovskite layer, less than 1 micrometer, compared to a thick layers of silicon, which has indirect band gap. And it has a long diffusion length. And the film can be deposited through the solution-based process in the lab scale. And that's the reason why a lot of researchers around the world are enthusiastic. So because it can be produced through a low temperature solution process. Has a device architecture. It's basically a so-called NIP structure. You have a N-type material and intrinsic perovskite, and P-type hole conducting material, and it has a fabrication process is more complicated than in looks. And basically, because it is water sensitive, you should perform everything, not everything, but film deposition inside a glow box. And the stability is the main issue of the perovskite film. The conventional large-scale solar technology, it should endure 20 to 30-year operation in very harsh conditions. And one of the weak points of the perovskite is that it is moisture sensitive. So moisture can degrade the perovskite film. So my research goal was to figure out the factors that contribute to perovskite degradation, and design and fabricate efficient, stable perovskite-based photoelectrodes for water solar splitting. Okay, and people try the PV electrolyte configuration to generate hydrogen from perovskite solar cells, and also they began to immerse the perovskite solar cell in the electrolyte, the integrated configuration to generate the hydrogen. So I also tried that to make the solar cell, perovskite solar cell, and immerse it in the electrolyte. And this is the how the photoelectrode looks like. And this is a cell, the electrochemical cell we have used to measure. And basically it shows a good photovoltage of 1 volt and high photocurrent with a nickel catalyst as a catalyst for the water electrolysis. And you can, as you can see here, you can generate the bubbles from the electrode surface. So it works basically. However, of course, the stability is the main problem. So it works for about a few minutes, and then it begins to decrease the photocurrent. And that's because there are a lot of pinholes on the solar cell surface. And through the pinhole, the water molecules penetrate through the device and reach the perovskite layer, and perovskite begins to degrade. So that's even faster in acidic or alkaline solutions. So we wanted to improve this situation. So the first approach was to use a more stable material. We knew that if you use a mixed halide for the perovskite material, it's more stable in humidity. So we tried mixed iodine bromide materials, and basically in the electrolyte, the stability was about the same, so no improvement. And next thing, we tried the pinhole-free HTM. The perovskite material is covered with the HTM whole transport material, and we found that there are a lot of pinholes there. So we switched the solvent to make a more uniform film, and we improved the stability somewhat from like 5 minutes to like 30 minutes. So better, but not enough. And we ultimately found that we need to lay down some kind of protection layer on top of the perovskite material. So this film should be conducting, because you need electrons need to flow from perovskite to the upper layers. But at the same time, it should be impermeable to solvent molecules. So it should be impermeable to solvent. So it's not easy to come up with a material with having the two contradicting conditions. So we basically mixed the PMMA, methacrylate polymer, and carbon nanotube. And this is how they look like. Basically, you have a PMMA layer, and the carbon nanotube is laid down inside the material. So it's conducting, but at the same time, it's impermeable to the water. So we're using this layer as protection layer. Basically, the stability has increased a lab to about more than an hour. And so another improvement, but again, there's also the small pinholes through the layers. So the final thing we tried was to use some kind of a eutectic metal, a low melting point metal as a protection layer, and we chose the fierce metal as a protection layer. Fierce metal is the eutectic alloy of bismuth, tin, and indium, and it melts at 62 degrees C, at very low melting metal. So you can easily melt and reapply to the device. So we developed a so-called mold transfer process. We fabricate the filled metal protection layer from the separate process and combine it with the perovskite cell. This is the actual device we have made and successfully seal the photoelectrode using this process. So from this process, we could elongate the perovskite stability to more than 10 hours. And this is, at the time, it was the record long operation. We showed that by suitably protecting the perovskite layers, even though the perovskite is very sensitive to the water, you can protect the perovskite cell so that you can use it inside the electrolyte solution to split water. Okay. Okay. Before I finish, let me switch gear and briefly talk about the another topic, which is the ion migration in the perovskite material. So I told you that the water can destroy the perovskite film, but that's not the only degradation mechanism. Another mechanism is the ion migration in perovskite. Perovskite is very unique in the sense that there is an ion migration at the room temperature, and that affects the perovskite film as a hysteresis and switchable photovoltaics and long-term degradation. So I thought that this is a very good topic to study, and there are a lot of questions unanswered. So, such as the does ion migration really occur? Because no one was sure at the time, and if it happens, what's the migrating ion species, and how do my ions migrate? Things like that. So I attacked this problem by applying the so-called selective blocking method. So here, basically, you sandwich your perovskite layer between the two electrodes and apply a current. And at the initial time, the ions and electrons both begin to move. However, as the time goes on, as ions are blocked by the metallic electrode, and only electrons can flow through the electrode, so the ions begin to cloud near the electrode surface, and that appears as a higher resistance. Basically, initially you have a lower resistance, and as time goes on, the resistance increased. So by this measuring this resistance, you can basically measure, separate the ion and electron contribution. So we have fabricated this ladder device, and this basic structure, you have a perovskite film sandwich between the two electrodes, and you apply a constant current and measure the voltage between the two electrodes. And as expected, you see that this increase in the voltage or resistance of the film. And from this measurement, you can separate the conductivity of the electron and ions. Okay, and by repeating this experiment at a different temperature, you can actually calculate the so-called activation energy. Okay, from this equation, and from the measurements, we found that the activation energy of the perovskite film is 0.57 electron volt. And by comparing this value to the ones from the theoretical calculation, we found that probably the migrating ion is the iodide among several candidates. In the perovskite structure, you can have a methyl ammonium ion or proton ion. However, the activation energy of those ions differ quite much from the theoretical calculation. Okay. So in summary, I hope I showed you that the perovskite material is extremely fragile toward water. However, if you apply a suitable protection layer, you can use it as a photoelectrode for water electrolysis. And secondly, the ion conduction in perovskite has been confirmed through the selective blocking measurements, and it seems that the migrating ion is the iodide. Okay, and for the final words, I'd like to thank my graduate students who has worked hard for each projects and produced a good results. And I'd like to also thank my research institutions such as Brain Korea and Mid-Korea Research and ICT Research Center. And thank you for your attention.
Okay, thank you very much for the nice presentation and very informative and interesting talk. And now we come to the question and answer session. For the audience, please use the QA button to asking a question. And before I read the question from the audience, maybe I starting with my question about this photoelectrolysis. As we know that currently there are very high efficiency of solar cell that available in the markets, maybe around 20% or some or close to that. How about the efficiency of this system, Prof? And how to improve the efficiency of this electrolysis system?
Okay, thank you for a good question. So basically, the a lot of people has been enthusiastic about the perovskite layer because it shows such a high efficiency. You know, considering that the perovskite film has been deposited through the solution process. Usually, the films from solution process at room temperature is very low. You know, less than 10%, less than 5%, even less than 1%. But this perovskite film, even though it's deposited at room temperature through solution process. Now the record efficiency is as high as 25%. Okay, so that's the reason why a lot of people, a lot of researchers around the world was amazed by this film. And for the efficiency of the perovskite water splitting, for now that's hard to tell because for water splitting, you need a voltage which is higher than 1.23 volt, or hopefully practically higher than 1.5 volt. Okay. However, photo voltage for the single perovskite film is around 1.0 volt. So it's lower than required. So basically, you cannot generate hydrogen in a standalone way. So for the unassisted water electrolysis, you need to develop a so-called tandem cell, which basically you combine the two layers to increase the voltage. So I know that effort is going on in the field, and hopefully in the near future, you're able to see some publications regarding that aspect.
Okay.
Mm-hmm.
Okay. There is still no question from the audience. So one more question from me, Prof. There is some defect during using of this system. Okay. Perovskite is also degrade with the water. So could you tell us another strategy which is possible to overcome this problem?
Overcome the degradation problem with from water?
From water, yeah.
From water, okay. I think I mentioned it, but I talked it fast.
You in your research you are using a coating like that.
Yeah. And I think even for the solid state solar cell, the protection layer is very important. Even for the current silicon cell, you have a protection layer, some kind of polymer or things like that. And for the perovskite layer is even more important. So of course you should have a protection layer, some kind of extreme super hydrophobic layer to block the moisture from entering the cell and reaching the perovskite layer. And secondly, having a good materials, of course, can be important. So for example, as I mentioned, here it is known that if you mix iodide and bromide, this material has a better stability toward the moisture compared to pure iodide material. Okay, so that can be another approach. So developing material with a intrinsically better stability toward the water. Okay, and usually if you have a high quality material, you have a less defect, and it is known that those high quality single crystal materials are more stable toward degradation.
Okay. Okay, thank you, Professor, for the good explanation. Please, if there is any question from the attendee.
I saw a message saying that someone raised
Okay.
his
Yes.
hand.
There is a question from Mr. Risa Suryana. How about the reproducibility of your perovskite structure?
Reproducibility of the perovskite structure.
Yeah.
Okay. That's a good question. To be honest, the reproducibility is still a big problem with the perovskite cell, especially because my main effort was to build a useful working device. So in actual fabrication of the device, you have a lot of issues. And even, these cells, the efficiency fluctuate according to seasons. Okay, for example, during the summer season, you have a humidity, and usually you have less efficiency. And during the winter, and you have a dry weather, and usually you have a better cell. And in a perovskite conference, I heard someone giving us a joke that someone made a cell because the researcher was making the cell in California, which is very dry. So that's the reason why they are having such a high efficiency. Okay, so yes, the reproducibility is a very good, important issue, and for the academic lab, you have a limited resources to control your humidity. So you have a more fluctuation. So, however, for the industrial scale, I think for the perovskite fabrication, you have to everything should get into dry room. Okay, the facility which is used for battery fabrication, so where you can control your humidity so that you have a more reproducible fabrication.
Okay, thanks you for the explanation, Prof. There is one more question from Uti from Polytechnic Atmi Surakarta. The question is there any prediction when the perovskite material technology can be manufactured commercially in the future?
Could you repeat the question again?
Is there any prediction when the perovskite material technology can be manufactured commercially in the future?
Okay, commercialization.
Yeah.
Okay,
commercially.
That's another good question, I think. So I think this is the very critical time for the perovskite cells. Now it has reached the 25%, which is compared to silicon cell, and it basically showed that it has a high efficiency. Okay, however, the stability is still an issue. So you need to show that you can make a very stable perovskite solar cell, and which is difficult and challenging. So if any company in the world can show the long-term stability, like 5 years, 10 years, then I think you'll be begin to see the perovskite penetration into the solar market within like 5 years and 10 years. So the critical point is the stability, and that's the condition of commercial development. However, I say it's not easy. Okay, even the second generation solar cell technologies such as CIGS and CATL, everyone in the field believe that those second generation technology will penetrate in much of the silicon market. However, the thing is that the price of the silicon cell has dropped a lot for the last decades, actually faster than expected. So, the market penetration of the next generation technology has been very low for that reason. So it's not only about the cost. So it's about the infrastructure and establishment. But at least for the niche market, such as the window attached solar cells, probably you will be able to see some perovskite cells within next 5 years, I believe.
Okay, thank you very much for the question. There is one, actually still many questions, but because of our time limit, could you please answer one more question, Prof, about the possibility of another catalyst instead of nickel? This question is from Mr. Aditya.
Okay, that's another good question. So I have used the nickel intentionally because nickel is the cheapest catalyst for water splitting. Okay, and especially for alkaline electrolysis. However, if you switch to acid environment, you need to use different catalysts, such as ruthenium oxide or iridium oxide, and those are more expensive. Okay? So that's another good topic, the catalyst. So if you can develop a new materials which can replace expensive ruthenium and iridium, there'll be another good topic. And as the hydrogen economy is advancing, and I'm quite sure that the water electrolysis, the electrolyzer technology is the area which is very important. So that's another good topic.
Okay, thank you very much for the detailed explanation, Prof. And because of our time limit, and finally we come to the end of the presentation, and we would like to say thanks again on the presenter, Professor Ilwan O, and to all the audience from their active participation. And hopefully this presentation will be beneficial for us. And thank you again for your attention, and good morning. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for your attention.
Thank you very much. And time back to the MC. Okay, Mr. Aditya. Thank you.
Okay, thank you, Professor Agus Purwanto, for your moderation. And also, I would like to thanks to Professor Ilwan Ho for excellent presentation in the first keynote speech. Now we will move to the second keynote speech. We are continuing our meeting to the next agenda. The second keynote speeches will be delivered by Professor Takahiko Miyazaki from Kyushu University, Japan. The keynote speech will be moderated by Professor Suyitno from Department of Mechanical Engineering, Universitas 11 Maret. To Professor Suyitno, time is yours.
Okay, thank you, Mr. Aditya. Ladies and gentlemen, the Honorable Keynote Speaker, Professor Takahiko Miyazaki. Professor Takahiko is ready?
Yes.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome Professor Takahiko Miyazaki, and I will read the curriculum vitae of Professor Taiko Miyazaki. He is a professor in Faculty of Engineering Sciences, Kyushu University, Japan, and his Master of Science degree was obtained from Renewable Energy and Architecture, the University of Nottingham, UK, 2003. And his Doctor of Philosophy is graduated from Tokyo University of Agriculture and Technology in 2005. And the area of the research from Professor Miyazaki is very outstanding. He is expert in absorption, heat pump, air conditioning, simulation, and renewable heat or renewable energy. And from the reputable manuscript, his got H index is very high, is 21. So, ladies and gentlemen, today Professor Miyazaki will be sharing with us his expert experience on the potential of latent heat load removal by activated carbon for energy savings of air conditioning system. So this topic is very interesting and very important in our today's life because our conventional air conditioning system may consume huge amount of electricity. So, ladies and gentlemen, to avoid the wasting time, please welcome Professor Taiko Miyazaki. Please, 30 minutes. The following, the virtual room is yours, Professor Miyazaki.
Can I share my screen?
Yes.
Okay. Okay, thank you very much for a very nice introduction. So today I will give my talk with this topic. So first of all, I deeply thanks to all the organizers for this very nice conference, and it is my great honor to speak as a keynote speaker. So my today's topic is about the research project collaboration with these members. So Ms. Charnisa, Dr. Mixik, and Professor Chotu, Professor Miyawaki, Dr. Nakabayashi, and also from UNS, Professor Vijayanta and Professor Rahamati, and Dr. Christian and Dr. Indriyan. So they are involved in this project. So I would like to introduce our research achievements so far. Let me start with a short introduction of my laboratory. So my laboratory is Thermal Energy Conversion Systems Laboratory in Kyushu University. Okay, so I work with Professor Chutu and Dr. Mixi, and also we have some technician or secretary, other staff. And one of the very interesting point of my laboratory is we have many international students. Now, from this semester, we have 10 PhD students, and all of them are non-Japanese. Actually, it is a problem. We don't have any Japanese PhD students, but we have very good students from worldwide. Okay. Also, for the master and the bachelor, the main students are from Japan, but nowadays we have more international students from all over the world for the master course. Now we have the students from Korea, China, Iran, Egypt, Ghana. So it is really welcome to come to Kyushu University for the master or PhD study from the audience today. Okay. So the focus of our research is the utilization of thermal energy. So my research is related to the thermal engineering, and especially I'm focusing on the utilization of low-grade thermal energy, which means low temperature, near the environmental temperature. The related technologies are the refrigeration and heat pump technologies. Especially, I work on the adsorption heat pump and desiccant dehumidification, which use adsorbents to drive these heat pump systems. Also, we test some mechanical vapor compression heat pumps. So because this is an issue related to the global warming. So the refrigerant of the mechanical vapor compression system is a very strong global warming greenhouse gases. So we have to reduce the effect of the refrigerant. And also, we have some research on the heat engine. And so especially the energy recovery from low temperature heat, organic Rankine cycles. And also we do some work on the dew point evaporative coolers as a heat recovery device, and also the thermally driving pumps. The topic today is related to one collaborative research project. And so it is the development of low-cost Desiccant air conditioning systems using activated carbon derived from biomass resources. This is a collaboration research project between Japanese JSPS and DGRSTHE. I don't know the correct pronunciation of Indonesia. So we started this project from 2018, and so this March, the next coming March, it will be finished. Unfortunately, this year we don't have any activity due to the coronavirus. So I hope we can continue some portion of this work next year. So this is the member of this research project. Okay. So this is a collaboration between Kyushu University and Sebelas Maret University, Indonesia. Okay, so let me explain the Desiccant air conditioning system. Desiccant air conditioning is a dehumidification system. So for the dehumidification, we use the solid Desiccant system, solid absorbent. Generally, this type of the rotor is used for the dehumidification. So for the large scale buildings, this rotor is very large, like maybe diameter will be more than a few meters. Or for the simple system, a small system, also it is possible to use some type of the block of the Desiccant material. So this is our test materials, and it has this honeycomb structure where it enhances the heat and the mass exchange between air and this material. Using this type of the Desiccant system, so the air is dehumidified and also it is cooled for the cooling application. So some systems use only this Desiccant rotor. This schematic explains some of the representative Desiccant air conditioning system. So this is a Desiccant rotor. By using this, the outdoor air will be dehumidified here. Okay. In some system, it uses the pre-cooling, because if we pre-cool the air, it will enhance the dehumidification. We will get more dehumidification from the cooled air. Because if you cool the air, the humidity, relative humidity becomes higher. So for this material, the higher relative humidity will enhance the dehumidification. Then after the dehumidification, the air temperature increase because of the adsorption heat. Adsorption is similar to condensation, so it will release the heat. So due to that adsorption heat, the air is dehumidified, but the temperature increase. Then we will cool this air to supply to the room. We don't need a lot of energy for this cooling. For example, we can use evaporative cooling. Evaporating cooling is a very efficient cooling way. Okay. But this rotor has to regenerate, which means remove the adsorbed water to continuously dehumidify. So this rotor is rotating, and the other side, we heat up this rotor to release the moisture. Generally, that heating is by the outdoor air or return air from the room, and we use some type of the heater. And then using this hot air, the moisture will be removed. So for this heating, we use any type of the heat source, but the main advantage of this system is we don't need very high temperature. For the silica gel, it should be like 100 degrees C, around 100. But for some new adsorbent, we don't need 100 degrees C. It can be 70, 80, or with some material, it is proved that it works with 50 degrees C hot water. That is really easy to get from the solar energy or any waste heat. Also, if this cooling is not enough, we use some additional system, like the hot air after the Desiccant rotor is heat exchange with return air, and it will be further cooled. This is some variation of the system, but anyway, the main part is the dehumidification by this rotor. So then cooling load of the air conditioner is largely reduced by separation of the dehumidification and sensible cooling. So this is dehumidification, and this is just sensible cooling. Okay. So with this separation, so the system can be energy efficient. Okay. So the first research theme within this project is produce low cost adsorbent, because generally the zeolite or silica gel or some advanced material is used for the dehumidification application, but they are expensive materials. They have a very good capacity, but expensive. So our trial is to produce very low cost activated carbon, and especially from the biomass resources. Okay, so she's one of my students from Indonesia, and her background is chemistry, so she can produce activated carbon by herself. Okay. So she took I'm sorry, I don't know that how to pronounce this, nutshells. And also she took some of the leaves or some wasted biomass within our campus. She collects these things and so make the raw material. Then this material is heated, and so it will be carbonized at this temperature. After that, this carbon is activated using the steam. There are mainly two different ways of activation. One is the physical activation, and another is chemical activation. If we use chemical activation, we will get better activated carbon, but it is more expensive. So our trial is very easy and low cost way to produce activated carbon also. So this is the steam activation. And then after that, to enhance the water absorption, she put some oxygen onto the surface of the material, which is oxidization. So she used the air to give some oxygen to this surface. So we did some analysis on the surface area and also the pore structure. So here, this is the chart before the activation, and this is after activation, and this is with oxidization. So it shows the micropore volume was enhanced with this activation. Also, surface area was increased. And so Yeah. Percentage of yield was 80%, which is good level. Then we tested the water absorption capacity of this material. Okay, so this is char, so it doesn't have the pore, so we don't expect a high water absorption. But by the activation, we can improve this water uptake. So the horizontal axis means the relative humidity. You can think this is relative humidity. The general material has higher uptake with higher relative humidities. Okay. And this vertical axis is water uptake per the gram of the material. Okay. So with this activated materials, we got higher, and also with the oxidized material, the water uptake was improved. So the maximum value will be near 0.5 gram per gram of the material. Comparing with the commercialized activated carbon, which was chemically activated and which has the better characteristics, the value is not so high. So this is the some commercially available activated carbons. And so this data was taken from one of our group member, his past research paper. This material has a maximum 1.2 gram per gram. So our material was maximum less than 0.5. So the value was twice this material, more than twice as much absorption, water absorption uptake. Also, this material is also good near 1.0. Okay, so compared to this material, our material is not so high water uptake, but these two materials are made by chemical activation and which are high cost. Okay, so then the second part, I'd like to explain the application. First, we would like to use those materials for the dehumidification. So let me explain the dehumidification is important in especially Indonesia or some the South Asian countries where the air is hot and humid. Okay, so this graph shows the monthly average temperature and humidity in Jakarta, Indonesia. Okay, so this data are taken as a representative data from this website. So temperature, the average high temperature for the month is more than 30 degrees C, and the low average is also about 25 degrees C. Okay, so within this temperature range, the humidity is high. So it is more than 70%. So in average, it will be like 80% humidity. If we plot it on the psychrometric chart, the horizontal axis is the dry bulb temperature, air temperature, and the vertical axis is the humidity ratio, which is the amount of the water inside the air, within the air, per kilogram of the dry air. So 1 kilogram of the dry air holds this amount of the water vapor steam. So from this data, we can calculate the humidity ratio, and with this high temperature, average temperature, it will come here. Like so water vapor of more than 20 grams is contained in the air. The relative humidity is about 80%. This curved line gives the relative humidity. This is 100%, this is 90, so this is 80%. Okay, so with this low temperature, average temperature, so also we can expect relative humidity 80%, and the humidity ratio is near 20 grams per kilogram dry air. So This is very high relative humidity ratio, water contents. So this is not comfortable as a room air. So by using the Desiccant air conditioning system, we will remove the water moisture from the air in this way. So if we have very high outdoor air, the Desiccant rotor can take the water, so the humidity ratio will decrease. But this dehumidification is a conversion of the sensible heat to latent heat to sensible heat. If we remove the water, the air temperature increase. So the temperature increase here. Then after that, we will cool this air to supply to the room. But this from the difference between 0 to 1 is a dehumidification amount. Okay. So to repeat this system, we will heat up some air to a certain temperature. For example, in this case, the air temperature can be heated to 90 degrees C, and then air is regenerate. Air regenerate this Desiccant rotor. So the air will take the water from the material, so air humidity increase and temperature decrease, and here the air is removed. So we can use this kind of system in building. Okay. From our material, so we cannot directly calculate how effective our materials are in that Desiccant system, but we can we did some theoretical study to calculate the dehumidification capacity of the material. So this is the adsorption isotherm from our material. This blue line is the adsorption isotherm when we are doing the adsorption. Because of the hysteresis loop of the material, so during the desorption, it goes this line. So, for example, the adsorption condition, we can set temperature 32 degrees C, relative humidity 80% from this, about this average. Okay, using this average, we will know the material can absorb, our activated carbon can absorb water at this amount, about 0.36 kilogram per kilogram, relative humidity 80%. For the dehumidification, we will heat up the air. Okay. So in our calculation, we set the heated air temperature like 40 to 80. The lower temperature, the less energy consumption, but the performance will be low. Okay. For example, if the desorption temperature, the air is heated to 80 degrees C, which corresponds to the relative humidity 30%. In this case, the material will hold about 0.08 kilogram per kilogram. Okay, so by the dehumidification, the activated carbon can hold the water at this amount. So the difference between this adsorption and desorption is the dehumidification capacity. By using this material, we can get this amount of the water from the air, and by heating this material, it will release this difference to the air. So this difference will be the capacity of the dehumidification. In this example, we can calculate the dehumidification capacity like 0.28 kilogram water from the 1 kilogram of the air. Okay, so this is the calculated result. The highest material is silica gel B type. So this is the adsorption sum of the silica gel B type. It has very high water uptake, but this green one is the general silica gel. So it has this adsorption sum line. Compared to this normal silica gel, our oxidized material has better adsorption dehumidification capacity at this regeneration temperature range, and especially if the regeneration temperature is low, so air temperature becomes low, this silica gel has less this dehumidification, but our material can keep certain dehumidification capacity. Okay, so which means our material is easier to release the adsorbed water with the low temperature. Also, if we use the very good activated carbons with this material, which are the commercially available material, compared to the silica gels, we confirmed they have much better performance, especially with low temperature. It has higher dehumidification performance. Okay. So this is the dehumidification material, the performance. And then so I would like to explain how it will improve the performance of the air conditioning system. Maybe I do not have much time, so I will just quickly explain what I did. I will skip some detail. But our material can release the water with lower temperature. That is because of this range. So this is adsorption isotherm. So with this relative humidity, like up to 0.4, it doesn't adsorb the water. So which means that once it gets certain water at high relative humidity, it will release all of the water, even the relative humidity of 0.4. Some material has to heat higher temperature to get lower relative humidity. If the adsorption isotherm is like this straight line, we need to heat up the air to get a very low relative humidity so that the water will be released. Okay. But our material has relatively low adsorption uptake at this low relative humidity range. So that is why our material, or activated carbon in general, activated carbon is suitable for low temperature regeneration. Okay. So this psychrometric chart explains the difference between the dehumidification and by this Desiccant material and the normal air conditioning. The normal air conditioning do the dehumidification by the dew point cooling. So this air is cooled to the dew point, and then further cooling, the water will be condensed and removed. So this is the dehumidification. But if the humidity is already removed, the air can be just cooled to a certain temperature. Okay. So if this air is cooled and dehumidified, so that we need to remove this enthalpy, like 20 kilojoules per kilogram. But for example, if this air is just cooled to 20 degrees C, the enthalpy difference is just 5 kilograms. Okay, so the difference will be very low. The required enthalpy difference is very low. Also, for our material, dehumidification requires less energy. So to calculate more detail of the heat pump performance, we did some simulation. I will not explain the detail, but this simulation is based on our experiment. So we simulate some material. I don't need to show a chart. So this is our heat pump experiment stuff. So our simulation is validated against this experiment. Okay. This is some example of the comparison between experiment and simulation. The heat pump will consume electricity at compressor. So this simulation simulates the heat exchange process in detail, and it will show the characteristics similar to the simulation and experiment against the compressor pressure ratio. So if then the compressor pressure ratio is changed, the subcooling of the refrigerant after the condensation will change. So this simulation can simulate reproduce this result, and also it will show the similar COP against this change of the subcooling. And then, so this will be the final slide. With the dehumidification, we need to cool the air to the dew point. Generally, the temperature will be lower than 10 degrees C. Okay. From our simulation, so if the evaporation temperature of the refrigerant is 8.5 degrees C, the cooling COP is like something 5 point something. But the dehumidification is done by the Desiccant material. The air doesn't need to be cooled to the dew point. So if we provide the air like 18 degrees C or less than 20 degrees C, it is enough. In this case, the COP will be improved, the 7 point something, and this is actually 1.5 times better than this case. So by using this dehumidification from Desiccant material, we can improve the COP performance of the vapor compression air conditioning system. Okay. So this is the main findings of our research so far. Okay, so this is all. Thank you very much for your kind attention.
Okay, thank you, Professor Miyazaki. Very detailed and informative research. And now we come to our Q&A session. So please, from the audience, if there is questions to Professor Miyazaki, you can raise your hand. Okay, there are some questions, Professor Miyazaki. The first one I will read from Eliza Tri Maharani. Okay, there is Nurwi Diana. Okay, please. Yes, Mrs. or Miss Nurwi Diana, please unmute your mic and directly give the question to Professor Miyazaki. Hello? Okay, directly the first one, Professor Miyazaki, this from Eliza Tri Maharani, this from 11 Maret University. The question is there any specific reason why the Desiccant block use the shape of honeycomb, which is hexagonal, or why you use hexagonal honeycomb for the Desiccant block or Desiccant rotor? Thank you.
This one.
Yes.
Yes. Mainly the air flow inside this channel, so it will be better to use the small channel, small diameter of this flow channel. Then the reason why we use this honeycomb structure will be just a structure of the whole material. Right? We cannot bind the small tubes. It is difficult. So with this block shape, this honeycomb structure will be reasonable to make a shape, I guess. But also there will be some more reason about the shape of the flow channel to the heat transfer and mass transfer, like circle or triangle or rectangular. So they might have some difference on the heat transfer and mass transfer. But I'm sorry, I didn't survey the detail about this.
Okay.
But mainly this structure will be some reason for the manufacturing or something. Yeah. Okay. So.
Okay, so this structure is much better than the other structure, isn't it?
The small diameter is important.
Yes.
Like 1 point something, a few millimeter, or. But if it's too small, it will increase the pressure drop. So there will be a certain optimized diameter. In this case, the diameter will be 1 point something millimeter.
Okay, I think it's clear for her to from your explanation, Professor Miyazaki. So the second question, Professor Miyazaki, this from Mr. Bambang Kusarjanta. Okay, the question is, why does activated carbon 900 oxidation have or has a better dehumidifier capacity regarding to the let's say activated carbon 900 or 900. Okay.
Okay, so better than this, yeah, the blue, comparing this blue and orange, right?
Yes.
So this difference comes from the adsorption uptake shape. This is the 900. The blue one is the oxidized material. By the oxidization, we will get better water uptake, especially at the higher relative humidity range. Sorry. If the relative humidity is 80%, the water adsorption uptake is higher compared to this orange. When we regenerate the material, we will use low relative pressure. Within this range, so the difference between the non-oxidized and oxidized is smaller than this, the improvement in the high range. So the dehumidification capacity is the difference between this adsorption and desorption. So because this ice storm is improved, we got more adsorption at high relative humidity. The difference between adsorption and desorption was enhanced. So that is the reason we will get better dehumidification capacity here.
Okay, and then maybe how about the surface area, Professor? This is a significant
the area is also
increase.
Include. Yes. Yeah, it has the higher surface area. Maybe because of the oxidization by air with this temperature, so the material will be further activated. So maybe the pore will be increased. Like here, we see the more pore volume. Then it will also contributed to the better performance, the higher uptake.
Okay, from the audience, maybe there are some other questions to Professor Miyazaki. Okay, Professor Miyazaki, from the real application, the activated carbon usually has a saturation time or saturation period. What about this activated carbon that your team have been developed?
I mean, time to the saturation.
Yes, saturation. Or the lifetime of this activated carbon.
I'm sorry, I don't have the data, but from our past experiment of the water adsorption, it is slow. Actually, it takes a long time for the saturation. But that is not really a disadvantage, because if we use this type of the water, we need very quick adsorption and desorption. But if we use some stable material, if we just set some material, or just we can put some activated carbon particles inside some container, then so if we have enough amount, we can use it long time. It can absorb the water all day, and maybe we can regenerate it night time or at a certain period. So now we didn't analyze the adsorption speed, But after we knew that solution speed, we can propose, we can design the suitable system for our material. Okay.
Okay, is there any questions from the audience? B? Okay, Professor Miyazaki, we have a limited time for the second keynote speakers. And okay, well done. If you have a question, please, still waiting. Hello, Mr. Wildan.
It's okay.
Okay. Yes, because we have a limited time, Professor Miyazaki, and I think there are still many questions from the audience, but because we have to continue for the next session. So, Professor Miyazaki, ladies and gentlemen, we would like to say thanks again to Professor Miyazaki for the very detailed and informative presentation. Hopefully, this presentation insight us and give some opportunity to make a collaboration and also next research and development. So hopefully this presentation is also beneficial for everybody, for the participant, and thank you for your attention. Good afternoon, Professor Miyazaki and all the audience. Assalamualaikum warahmatullahi wabarakatuh, and I give back the room to Mr. Master of Ceremony, Mr. Adit. Thank you.
Thank you very much.
Thank you, Professor Suyitno. Now, we will move to the next agenda. First of all, I would like to say thanks beforehand to Professor Suyitno for the moderation, and also I would like to convey the best regards for Professor Takahiko Miyazaki for outstanding insight in his presentation. In the third keynote speech, it will be delivered by Professor Muhammad Azizi Abdul Rahman from Malaysia Japan International Institute of Technology, UTM, Malaysia. The keynote speech will be moderated by Ferry Adrianto, PhD, from Department of Electrical Engineering, Universitas 11 Maret. To Dr. Ferry Adrianto, time is yours.
Thank you for the time. Good morning. Assalamualaikum, Prof. Muhammad Azizi Abdul Rahman. Yeah. My name is Ferry Adrianto. I am from Department of Electrical Engineering of 11 Maret University.
Hi.
Ladies and gentlemen, we'll be hearing a presentation from Professor Muhammad Azizi Abdul Rahman from Malaysia Japan International Institute of Technology, UTM, Malaysia. Before we get started, I wanted to take a few minutes of the times. The presentation time for keynote speaker is 50 minutes. Oh, yes, and 40 minutes, sorry. 30 minutes for talk, 8 minutes for Q&A, and 2 minutes for moderator and keynote speaker switch. For the discussion, please write the question by using the Q&A button, and please do not use the chat window. I will introduce the speaker for this session. Professor Muhammad Aziz Abdul Rahman is an assistant professor in Malaysia Japan International Institute of Technology, UTM, Malaysia. His expertise on biological processing and control, robotic, and AI. Okay, I will start. Yeah. His education, Bachelor of Engineering for from Liverpool University in 2005, and Master of Science in UPM from UPM Malaysia in 2009, and then PhD degree from Shibuya Institute of Technology Japan in 2013. Professor Muhammad Azizi get notable achievement and awards from UTM Science Award in 2019, UTM Malaysia, and also Gold Medal Award 2019 from Icon Canada, and Gold Medal Award in 2017 from MTA Malaysia, and Gold Medal Award in 2016 from Inatek Malaysia, and Yanai Hisayoshi Memorial Award in 2013 from Shibuya Japan. It's very more of a notable achievement and awards. He has he supervised 6 PhD student, also a 6 master student. 1 is ongoing, and 5 graduates. Yeah, he also give a talk and speech in 1 keynote speech and 5 invited speaker. Professor Muhammad Azizi Abdul Rahman more published in Scopus Index publication journal and POS Index publication, and also book chapter and original books, which Index Scopus is 10, and also he managed research grant from private international level, national level, and in university level. I would like to welcome our presenter, Professor Muhammad Azizi Abdul Rahman. He will deliver a presentation with the title Personalized Gait Treatment Using Passive Controllable Ankle Foot Orthosis. This is very nice topic, because by using this PITFO, passive controllable EFO, it developed to fulfill a demand consisting of several research work and also have detection and smart actuator design and controllable development. I would like to welcome our presenter. Yes, ladies and gentlemen, please welcome Professor Muhammad Azizi Abdul Rahman. The room is yours.
Thank you very much, Dr. Ferry Adianto, for a lovely introduction. So allow me to share my screen.
Okay, please.
Can everyone see my slide here?
Yes. Yes.
All right. Nice. Let me put it on slideshow. Well, okay. Assalamualaikum, and a very good morning to all of you. Okay, hope everyone is in good health condition. Yeah. So we are still struggling to live in this new norm during the pandemic. Okay, moment. Okay, and this COVID-19 is still around us, and indeed we need to be very extra cautious. Okay, by comparing to other keynote speakers that we have this morning, I am nobody. I'm just a guy who start my research for the past 5 years, and then try to position myself in research community. So today I would like to share my current research. Okay, to share my current research entitled "Personalized Gait Treatment." Okay, using passive controllable ankle foot orthosis. Okay, before that, allow me to introduce a little bit about my research group. Okay, where I came from. Currently, I am head of Advanced Vehicle System Research Group. Okay, which was established under Office of Deputy Vice Chancellor of Research and Innovation. Okay, University Technology Malaysia, and we were at we are located at the central of Malaysia, okay, Kuala Lumpur, our campus. And what I would say, okay, I'm proud to say that, okay, Dr. Ubaidillah and Dr. Fitrian, okay, currently from UNS, okay, were graduated, okay, from our lab. Okay, they are very, very good researcher and impactful, productive fellows. Okay, so let's move to my introduction slide. Okay, I believe, okay, most of you, okay, have watched or seen, okay, this movie Iron Man. Okay, let's have a look at this short clip. It was first released in 2008, okay, about Tony Stark, an industrialized, okay, who designed and developed an armored robot suit, okay, which I believe this is the most advanced robot suit. In order for, so this technology can help Tony Stark to perform unhuman movement, so he can save the world, something like that. So nowadays, a science fiction movie convey to us that the robotics field is effortless. In this clip, for example, yeah, Iron Man suit, okay, enable Tony Stark to perform the unhuman movement. Okay, so for instance, if you look at the thruster, okay, at the foot pump, allow him to float and fly in the sky, okay, lift a heavy object, and even shoot a laser beam. Okay, the helmet is not merely a decoration, for example, yeah, where he can do a real-time communication with an artificial intelligence system, Jarvis, okay, that provide important suggestion during a hectic scene. Okay, there is also an arc reactor there. You might see there, okay, as the power supply that lasts long despite small dimension. Okay, given that many kind of Iron Man technology, this suit can still fit, okay, in a small suitcase, and be worn in a second. Okay, look at that. So this technology is intriguing. Okay, so yes, that one. Oh, it's 7 minutes, so I have to stop this and move to the next slide. So the dream is huge and the movie made it look easy. However, the reality is harsh, and this development is currently not trivial and needs more effort and what do you call that, hard work, okay, to realize this kind of technology. So the development of such sophisticated robotic suit require many effort and dedication, okay, but current result is still far from the perfect. Okay, let's move to the next slide. So ankle foot orthosis, or FO, what is it anyway? So ankle foot orthosis, okay, is a leg brace, okay, which designed to assist walking gait around the ankle. Okay, especially in the walking gait rehabilitating process. So the robotic technology improve current equipment. Okay, this especially this mechanical AFO. Okay, so it's a solid leg braces, okay, that cover the foot until the calf. Okay, here, for example, from here, okay, the foot until the calf here. So AFO is designed to assist walking gait around the ankle by locking the foot plantar flexion, okay, and then preventing foot drop phenomena or foot drop disease on post-stroke patient, especially for those who are in a rehabilitating process. Okay, so the effect of AFO after usage is shown in this figure. If you may see this gait, should be the normal one and the irregularity. irregular. You might see this one. Okay, so foot drop happen when our leg, okay, is not stable. It's like this, and it just drop, okay, throughout the end of the walking gait. So if you you can see this video, you see the difference. It's not normal. It has disability and irregularities of walking gaits. Okay, especially look at this. Okay, this is the one of the foot drop symptom. Okay, so they use AFO, mechanical one, okay, to regain walking ability. So you may see that the post-stroke patient initiate the foot contact on the heel, okay, shown in a solid gray here, instead of the toe as shown in the black dashed line here. Okay, so after using FO, okay, the user will begin their initial contact on heel instead of the toe, okay, thus improving walking stability. And this is part of a small thing about walking, but it's quite critical. So basically, preventing foot drop is just one part of a complex quasi-periodic system, okay, such as walking, but it is a critical function that increase walking stability. Okay, so in other words, it reduces the probability of falling on a post-stroke patient during rehabilitation. Okay, despite that, the solid AFO needlessly, okay, restrict the push off, okay, increasing the walking energy cost. Okay, so here in this work, the robotic technology improved the FO, okay, by attaching actuators, smart actuator, I believe, okay, on the articulated joint knee, okay, to control the gait movement. Okay, so as a result, the improved FO can still have the locking features, okay, without unnecessary foot off restriction at the same time. Okay, so let's move to the next slide. So AFO prescription. Usually, a doctor or therapist, okay, will prescribe the FO for patient with gait impairment. Okay, so here the design and the prescription of FO are not about suggesting the advanced FO to the patient. Okay, the most important thing is that the FO should match, okay, the patient needs in real time. Okay, for instance, okay, an amputee patient requires an active powered FO that can generate the walking movement for him, okay, for him or for her. Okay, then months upon treatment using the active AFO, okay, the patient is diagnosed with a different FO that partially support walking. So he or she later can regain walk naturally. Okay, so this example shows that AFO, okay, is an iterative and individual process, as well as collaborative. Okay, so fabrication of AFO, okay, should be done effortlessly, okay, without consuming too much time. Okay, it takes some time to get a new FO that is suitable for the patient that needs that in that time. Okay, so this is an expensive and long process to have a FO design and develop new one. Okay, so in this research by Kane in 2018, okay, he come up with this structure of AFO prescription. Okay, they claim that it's an iterative, collaborative, and individualized process. So what is it made? How is it used? And what is the support, the challenge that you need? Okay, for the patient as well as for the therapists or doctors. All right. If the AFO, okay, if the AFO fabrication process, okay, takes a long time and iterative. Okay, so then the fabricated AFO may not be appropriate anymore. Okay, so the FO design and prescription are also a collaborative process, because the patient, okay, may need the family helps. Okay, for example, okay, to put on the FO. Okay, the family should have basic knowledge about the prescribed FO. Okay, to be attached in the right way, in the proper way to support the patient. Okay, so beside that, the family should also plays an important role of financial support for the patient, right? So the real challenge of prescribing an FO is whether the patient and his or her family can purchase the expensive FO or not. It depends on the technology that attached to the FO. Okay, next slide. The goal of this research, actually, by having the FO prescription that I mentioned before, so we have filter it, okay, we select it, okay, in terms of low cost, easy to fabricate, long-term usage, durability, for example, okay, safety, and it can be customized based on personal use. Okay, so all these things we mix up, and then we come up with the personalized gait treatment using passive controllable ankle foot orthosis, or just PCAFO. Okay, in other words, we have this original what do you call that, boot, okay, leg boot, okay, converted into not so high tech, but it has a technology inside this, with the smart actuator, MR braking, magnetorial brake, a smart actuator. We put encoder to have a feedback, and then foot switch underneath using the sustainable MRE, magnetorological elastomer. So improving the support equipment, okay, such as FO, is to optimize the patient benefit, okay, when using FO in gait rehabilitation. Okay, the patient gets the most benefit of gait treatment from low cost, easy to fabricate, safe, long-term usage, okay, and personalized FO. So the robotic technology, okay, can be the means to achieve this. Okay, so by having an actuator here on a personalized FO, so the mechanical properties of an FO can be changed accordingly. Okay, so the requirement to fabricate a new FO, the new FO can be for the neglect, okay, making the FO to be used in the long term, okay, rehab process. Okay, so because of this, the patient can save their money, okay, I mean, in a costless, okay, for buying a new prescribed FO. So however, the development of such FO is a challenging task, a non-trivial task, okay, so we should require effort and dedication to making this this prototype, okay, happen, unlike what we had seen before, okay, in the science fiction movie. It's looked too easy, right? So ladies and gentlemen, our ongoing research are more focused on this passive controllable FO, or PCAFO, and this is actually interdisciplinary, okay, subject, okay, where it include the mechanical, electrical, okay, of chemical or material science in engineering, as well as biomedical research. So in this PCAFO, okay, it is equipped. Okay, the difference between normal FO, original AFO, and or mechanical linkage AFO with this PCAFO is equipped with smart actuator, which is MR brake for controllable stiffness. So in line with the goal of this personalized AFO for the patient, so our team has developed this PCAFO, and this the PCAFO research consists of several works, okay, such as gait detection, smart actuator design and development, and as well as controller design and development. So in this work, the detail of the research, okay, related to developing the PCAFO for personalized gait treatment will be presented later on. Okay, so next. Okay, this slide shows us about gait classification, okay, using biosignal. Okay, if the walking pattern, okay, known as gait, is one of the most common form of human locomotion. Okay, so the gait, the walking gait is a complex, unique, and quasi predictive phenomenon. Okay, where the gait cycle is similarly at first glance is similar. It's similar is at first glance, but actually it's not in the end. Okay, and that's mean from the stance phase. Okay, if you look at here, from the stance phase until the swing phase, for the full walking pattern, okay, it's not the same, it's not similar for every cycle, but in the end, it's not it's how to say it's not what do you call that? The gait cycle actually is not the same, okay, throughout the full entire cycle of walking gait. So, however, the walking gait, okay, can be identified according to each phase, okay, consisting of several gait phase. Okay, so NFO, okay, should control each designed gait phase differently. Okay, from here, for example, okay, gait phase, okay, feet forward, okay, heel strike, okay, heel off, toe off, okay, and then contact, initial contact, and then foot forward again, and then it's the cycle goes around. Therefore, the controller, okay, must be able to identify, okay, the appropriate timing of each gait with accuracy. Okay, information from the user, especially in this case EMG. We use muscle activity. Okay, EMG, electromyogram. Okay, ankle position. Okay, ankle position, limb acceleration, bending moment, and of course the intention of the user. Okay, and their interaction, okay, with environment, especially ground reaction force, GRF, okay, on and the foot contact, okay, with the ground, can be used. Okay, these features can be used to identify the gait phase, okay, using sensors. Okay, in this case, we have the foot switch device as a sensor here. Okay, so inaccurate gait phase detection mean insufficient control that we can we will have a problem to develop, okay, to design later on. So, for example, the gait is classified into a swing, into a stance and swing phase. Okay, the swing phase require rotation movement in the plantar flexion movement. Okay, from here to here. Okay, so this is the gait phase comparison when you detect by using a foot switch for the solid blue line here. Okay, it has just 0 1 0 1 0 1, just on off on off on off, detect, okay, undetect, detect, and undetect. So this the notation here show this is the heel strike, okay, going to toe off, okay, lock it at heel side and then lock at the toe off, right? So nevertheless, the controller identify the controller identify as a stance phase that require the dorsiflexion movement. Before this plantar flexion and then dorsiflexion movement. So as a result, the controller will generate a dorsiflexion movement instead of plantar flexion. Okay, so the wrong action, basically the wrong action could lead to a fatal injury of the user. Okay, if you cannot control relatively, okay, with this for each phase, so it may injure the user. So therefore, sensor and gait phase detection method must be properly selected to ensure the accuracy. Okay, these are the citation, okay, from our works, okay, related to biosignal gait classification. Okay, next is how the Picasso stiffness control using fuzzy. So gait detection by utilizing tibialis, okay, anterior, KTA or gastrocnemius EMG. Okay, here. So the dorsiflexion and plantar flexion. Okay, has been experimented. Okay, in this work since 2006. Okay, so we start to figure out which control that's suitable for this kind of device. Okay, so initially a fuzzy classifier based on EMG signal is used for classifying, okay, the walking gait into two phase. Okay, or we need to just discriminate between stance and swing by having EMG muscle activity and fit into the controller to make sure that, okay, which one is stance, which one is the swing phase. Okay, so the fuzzy classifier input, the classification features were statically properties of segmented stance and swing EMG signal, okay, such as estimated parameter values of Cauchy distribution. We use Cauchy distribution. So for this fuzzy box, okay, we use triangular and Gaussian membership function that compare in terms of classification accuracy, okay, by using different healthy subject. If you want to see the Pica4, okay, attached with MR brake, okay, control with fuzzified input from EMG, okay, EMG biosignal and ankle position. So the output will be the current ampere, okay, driver to the coil in the MR brake that attached to the Pica4, and it should control the swing phase and the stance phase. Okay, so if you look at here, the ankle position, okay, the EMG signal is either active or inactive. So you have the forward, stand up, and then the backward. Okay, low, medium, and high. Low, medium, and this is the membership function. Okay, so ladies and gentlemen, so as a result, okay, the Gaussian membership function perform better than the triangular membership function to detect the walking gait. Okay, even though the triangular membership function is the most common, the Gaussian, okay, membership function can be considered in pursuing gait detection. So be remembered, this membership function, okay, design depends on the human factor, which are vulnerable to unpredicted error. Okay, so these are the reference, okay, that we use to develop this kind of control system. Okay, let's move to the next slide, slide number 10. Okay, this stationary test, okay, during isotonic content is another enhancement, okay, from using a fuzzified. We classify it into what do you call that? Stance and swing and stance phase. So we use, in this case, we use intelligent method approach, okay, the neural network, okay, as a classifier. Okay, the same thing to extract the feature, okay. In this case, since the features extract were signal statical property, so the stationarity, okay, of the signal must be confirmed in the first place. Okay, so this stationarity test of EMG signal during isotonic contraction, okay, such as walking, already conducted. Okay, so the stationary test method were selected as reverse arrangement RA and a modified reverse arrangement MRA. Okay, so to aim the aim is to identify the most suitable window length, okay, for sampling the EMG signal in a real-time application, okay, such as gait control using FO. Okay, so the result show differences, okay, in average signal stationarity, okay, with window size of 100 millisecond, 500 millisecond, and 1000 millisecond. Okay, however, almost 90%, okay, was obtained when sampling the EMG signal using a window size of 200 millisecond. Okay, so the sampling window size together with the processing time, okay, should be less than 300 millisecond, and the window size of 200 millisecond is applicable for this kind of isotonic contraction stationary test. Okay, so we utilize Levenberg-Marquardt algorithm for this classifier in order to produce output for the controller input. Okay, later on to develop a new type of controller. Okay, so in this graph, okay, in this result, it shows a comparison between ANN, okay, and foot switch. How this ANN can reflect directly, okay, precisely or accurately, okay, to the foot switch reference, okay. So it almost replicate, okay, the reference signal here, okay, either on or off, 1 or 0, okay, with associated to the time in millisecond. Okay, so we're done with the EMG signal stationary test. So the figure, it says after confirming, okay, the window size of sampling and processing domain time domain EMG features in real-time application. So the classification method is changed into neural network, as I mentioned just now. Okay, apparently the neural network, okay, is adaptive, okay, to the new data sets because of the learning factor, the learning ability compared to the fuzzy inference, okay, method just now. Okay, similarly, the gaits is classified, okay, into two focal phases, okay, stun and swing, okay, started by heel strike and toe off. So the developed ANN employs the Levenberg-Marquardt, okay, algorithm with 5 time domain features, okay, as the input. Then actually it successfully achieved 87 classification accuracy of the stun and switch, as shown in this figure. So the results show that the timing different, okay, in detecting the stuns and the swing is less than 70 millisecond, okay, which is considered acceptable in this case. Okay, so thus we can remark that classifying or discriminating the gate phase based on EMG using the NN method or for the FO controller is achievable or promising. Okay, so ladies and gentlemen, the next slide is about hybrid magnet MR elastomer for gate detection. Okay, smart material such as this hybrid magnetoradial elastomer or just MRE, okay, considered, okay, for is considered for this for detecting the gate phase. Okay, so the graphite, okay, is introduced, okay, as additive to the hybrid MRE, okay, which enhance the conductivity and rheological properties of the hybrid MRE to be used as a force sensor. Okay, so in principle, the main concept of detecting the gate using the MRE is the same as foot switch. Okay, so we consider this is as a foot switch using the MRE. Okay, which is detecting the foot contact by attaching it, okay, underneath our foot insole. Okay, however, MRE offer more flexibility and durability. Okay, firstly, the shape of the MRE can follow the foot contour, okay, since it is made from elastomer or rubber base. Okay, so secondly, the rubber stiffness, it can be adjusted. The rubber stiffness can be adjusted according to the applied magnetic field. Okay, thirdly, affecting thus it will affect the MRE durability. Okay, last but not least, the resistance of the MRE is changed due to weight. Okay, this is the good factor that we can have this material as a force sensor. So therefore, not only detecting foot contact, but the MRE can also be used to measure the ground force reaction. If you may see, this is the sample of the MRE, okay, the rubber-based elastomer. And then this is the test rig that we developed, okay, in collaboration with UNS, okay, to have a force, okay, and magnetic field to energize the particle inside the elastomer, and then force, and then what is the current change with reflect to the weight, force, and magnetic field density. So the resistance is the important parameter that we want to measure here. Okay, here it is the sample of the experiment, okay, having resistance versus weight, okay, with the maximum weight of 1 kilo, okay, with a different Tesla, okay, 0 Tesla, okay, 0.18 Tesla and 0.25 Tesla. Okay, this force, okay, has been measured with respect to resistance, okay, with a simulate experimental test with this test rig, and then simulation. So it shows that the hybrid sample and the sample resistance given the weight and magnetic field variation. Okay, so it's possible that a smart insole, okay, which is customizable and able to detect the gait phase, okay, and can be developed, okay, in the future by using this kind of smart material as the foundation. Okay, so we move to the next slide. Okay, this is about the developing smart actuator, okay, small scale MR brake, okay, for gait assistant. So articulated AFO can be controlled as active or passive depending on the actuator. Okay, so example of active actuator are pneumatic, okay, DC motor, okay, direct current motor, and series elastic actuator, where they can generate, yeah, or active leg movement. Okay, on the other hand, okay, several passive actuator are spring, damper, okay, solenoids, and of course these MR devices, which is either damper or brake, okay, where they help maintain the ankle movement in principle. Okay, so in this work, the mentioned passive actuator, the MR device, okay, the smart actuator, is a semi-active actuator caused by its mechanical properties, such as the braking or the damping stiffness. That can be proportionally controlled according to the induced current here. Okay, so MR device utilize smart fluid, okay, to change the mechanical properties, okay, when subjected to a magnetic field. Okay, the MR fluid solidified in an instant. Okay, so the solid level, okay, depends, okay, on the magnetic field value. Because of this, the stiffness can be controlled. Okay, so the drawback, okay, however, the drawback is the MR fluid tend to sediment, okay, when the device are not used for a long time. Okay, if you leave it for a long time, okay, the fluid, okay, tends to sediment. So the MR grease, okay, alternatively another form of MR material, okay, solve the sediment problem. Okay, but the responsive is very slow, okay, compared to the MR fluid. Okay, so therefore the MR grease is not suitable for semi-active walking gait control in real time. Okay, if only the stiffness is fixed across the gait instead of being controlled, it may be superior to MR fluid. However, a comparison of MR brake stiffness resulting from using this MR fluid or either MR grease are still further discussing, okay, by several researchers. Okay, so in this slide it shows that two type of smart actuator. So in 2017, I believe, okay, we developed a palm size MR brake, okay, intended to control the ankle stiffness of the Picasso. Okay, so this is the drum type MR brake, okay, shown here, okay, has a limited size, which was 45 millimeter in diameter and 30 meter thickness. Okay, because the weight should not exceed 500 grams. Okay, this is the limitation for the Picafor. So if the actuator is too heavy, then the Picafor might become a burden instead of assistant to user. So there is a coil inside the MR brake to provide the serpentine flux. So we use commercial MR fluid, okay, by Lot Corporation to fill the gap of 0.6 mm, okay, between the shaft and the inside wall here, okay. As a result, the MR brake, okay, can generate 0.26 Newton meter when induced by 2 ampere current. Okay, the peak braking torque can be improved by decreasing the gap actually. Okay, for instance, when the gap is changed to, change to 0.45 compared to 0.65 before. Okay, the peak braking torque become 0.3 Newton meter. Okay, which is higher. Okay, however, the braking torque is too small, okay, for FO application. Also, the lesser the gap, the harder the fabrication of the process of this MR brake. Okay, so later, as of improvement, the drum type MR brake was transformed into a T-shaped MR brake. Okay, as shown in this figure, it's T-shaped like. Okay, as the name suggests. Okay, which increase the active braking surface area. The gap decreased from 0.65, okay, to 0.25. Okay, meanwhile, the other parameters such as dimension and MR fluid type were maintained, okay, under the same constraint. Okay, so as a result, the peak torque improved, okay, by 10 times, okay, where the maximum 2 ampere of current induced generate 2.1 Newton meter, okay, of the stiffness torque lah. Okay, however, the stiffness torque is still considered small compared to other MR devices. Okay, in some cases, okay, it can reach up to 24 Newton meter. Okay, this is the improvement that we want to further improve. Okay, so the desired performance of the MR brake actually should be balanced with the available resource and constraint, of course. Okay, so developing a small scale MR device, okay, which produce high stiffness, okay, is a very challenging task and non-trivial, as I mentioned. Although the currently developed MR brake can partially support the ankle torque due to the low stiffness torque, the positive effect on the FO users can be observed by controlling the stiffness accordingly, okay, to the detected gait phases. So it's not about how you design how well you design the MR brake, but the control design is more important in this case. So, ladies and gentlemen, the next slide is about ankle velocity reference estimation, okay, for that Picafor. So the controller is essential part of developing an FO system, beside, okay, optimizing the hardware structure based on the sensor and actuator selection. So here we a dedicated controller, okay, is developed to control the ankle damping stiffness using MR brake in different gait phase. Okay, initially, as mentioned before, the Picafor system employ a fuzzy FLC with 2 inputs, which are EMG and ankle position. Okay, and 1 output, which is voltage to induce the current. So the fuzzified output combine the gait classification based on gastrocnemius EMG and stiffness control control based on the ankle position. Thus, in this controllable stiffness, okay, method, okay, the foot drop prevention is achieved while at the same time allowing, okay, plantar flexion during the stand phase to shift the body weight forward. Okay, it helps, okay, the user to move it to walk naturally. The bad side is since the FLC is an open loop control system, so the damping stiffness references amount, okay, must be determined through a trial and error process, which is time consuming. So we investigated alternative control reference such as using ankle velocity in 4 gait phases: initial contact, okay, to foot flat, okay, foot flat to heel off, okay, heel off to toe off, and the last one is the swing pace. Okay, this is the most critical part. Okay, the swing pace. The idea is to generate damping stiffness, okay, using the MR brake whenever the ankle velocity exceed the reference. Okay, assist just we just provide assist as needed. Okay, otherwise we don't have to do to control the velocity. Okay, so the investigation result shows that the ankle velocity has a proportional relationship with walking speed and BMI, which is a body mass index. Hence, it can be estimated based on this common information. Okay, just using the walking speed with ankle speed velocity and body mass index, so we can estimate the reference. So compared to previous study, where only walking speed is considered as an estimator, the inclusion of body mass index has improved the estimation while realizing a personalized Picasso control stiffness. So this figure shows the PID controller of the Picasso calculates the appropriate stiffness based on error and activation condition. Okay, as a result, the Picasso with the ankle velocity reference, okay, can achieve positive assistance in ankle kinematics and muscle activity, which is EMG. Okay, as shown in the figure, okay, both normal and overweight subject here, okay, tibius anterior and gastrocnemius muscle activity reduced when they walk using Picasso, okay, assisted Picasso with control stiffness. So if the fixed stiffness is used in normal subject, then trial and error method is necessary to confirm that the medium stiffness is the appropriate stiffness level. Okay, then the control stiffness result, okay, in positive assistance, okay, in positive assistance superior to high stiffness, okay, slightly inferior to medium and low stiffness, right? However, the references, the reference determination, okay, does not require trial and error, since the ankle velocity reference estimation can be predicted, okay, straightforward, okay, using this type of this kind of approach. All right, hope I think this is the last slide that I have. We go to summary or conclusion. We come to the conclusion now. So a passive controllable FO or PKFO system, okay, which include several research work, okay, such as gait detection, scale actuator, design and controller of the development, design and development, okay, was developed to achieve personalized gait treatment goals. Okay, so while ensuring the light and the compact hardware structure by selecting a proper sensor and actuator is important, the controller also proved that to be essential. Okay, so the latest version of the Picasso system utilized MR brake, okay, to control the walking gait based on ankle velocity reference. Okay, the user's common information such as walking speed and body mass index is the estimator, okay, for estimating the ankle velocity reference. So when using the Picafor with ankle velocity reference, the subject's muscles activity reduce. So relief to MR break due to MR break generates damping stiffness only when necessary. Okay, because of this, a personalized gait treatment using the Picafor system is achieved. And again, I think that's all from me. Again, I would like to thank this wonderful organizer and secretariat for their hard works, okay, to run this conference virtually. Okay, assuming this work is at initial stage of development, so I would like to seek collaborators among us, okay, all around the world to join our team for further R&D. So with that, before that, I would like to share. Okay, this is my information, and this work actually in collaboration with Institute Technology Telkom Surabaya. Okay, this is the person in charge, okay, in IT Telkom Surabaya. You may contact him, okay, for further research, collaboration, and development. So, with that, I pass this session to moderator. Over to you, Dr. Ferry Adianto. Thank you very much.
Thank you very much, Professor Muhammad Aziz Abdul Rahman, for addressing this interesting topic. Now we have Q&A session. Yeah. We have two questions. First, from Mr. Meyanto Eko Sulistyo, is from Electrical Engineering Department, Universitas 11 Maret. His question, how is the ankle foot orthosis applied to stroke patient? Yeah. How is the ankle foot orthosis, EFO, applied to stroke patient? Okay, please, Professor.
Okay, sorry about that. Okay, where is the... Okay, can you hear me again? Yeah. Okay, actually, post-stroke patient, if the post-stroke patient is diagnosed, okay, with this foot drop phenomenon, okay, that's the specific what do you call that, symptom that post-stroke patient need to be in rehabilitation process. So in this case, walking ability, if the person of the patient who has diagnosed with the stroke, especially from not too severe, maybe mild stroke, okay, they may have disability, okay, to walk properly. So in this case, we provide this kind of a tool, I mean the measurement device or this health care device to control their, to help, okay, the person, in rehabilitation process to regain its walking ability. So that means it's just a tool that help a patient to regain his or her walking abilities. That's all. This device, if it's pure mechanical, it doesn't mean anything. It's just if you have this Picafor with the control and all this parameter measured, so it will help what do you call that, the patient, okay, to improve their walking ability faster rather than use original mechanical link AFO. I hope that answer your question.
Okay, thank you. I think the next question is similar with the previous question. It's from Rizky Novitasari from ITS Surabaya.
All right.
AFO PKFO suitable for patient with arthritis or other disease who cannot walk because of ankle pain or for therapy, and does it work the same way?
Okay, this way. If the as I mentioned, if the patient is diagnosed, not all a stroke patient, okay, having the same symptom with foot drop phenomenon. So if the patient is diagnosed, confirmed, you need to rehab, for example, you need to rehab because of your foot drop phenomena, you have the symptom, look like foot drop phenomenon. Yes, this device, this this Pica4 can help to get to regain his or her walking ability faster rather than normal, for example, for example, but it hasn't what do you call that, tested yet in terms of the duration. But I believe the thing is we want to control how our walking, especially at the swing phase, not the stance phase. So the swing phase, when the foot drop happen or drop foot happen, okay, it cannot balance. It cannot balance or maybe the walking stability is not normal. So this irregularity can be can be solved, okay, using this Pica4. Okay, unless the patient is confirmed to confirm to have what do you call it, to be diagnosed, okay, to have foot drop phenomenon. Other than that, I'm not sure about that. I hope I answered the question correctly.
Okay. Okay. Due to we have limiting times, maybe now is we'll finish for this session. Okay, ladies and gentlemen, finally we come to the end of presentation. We would like to say thank again for Professor Muhammad Aziz Abdul Rahman for the informative and interesting talk, and also to IDN for your active participation. We believe this presentation will be beneficial for everybody. Thank you again for your attention, and good morning, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Bye-bye.
Okay, now the time will I give to the Master of Ceremony, Mr. Aditya, please.
Okay, thank you, Dr. Ferry Adrianto, for excellent moderation. And also, I would like to say thank you and best regards to Dr. Azizi Abdul Rahman for his excellent and enlightening presentation in this keynote speech. We are now taking a break for 2 hours. Kindly enter this meeting room again in 12:15 Western Indonesian time to listen to the 4 keynote speakers. So, okay, thank you. See you soon. Welcome back to Icimece 2020. Respected participants, including keynote speakers and moderators. We are now continuing our meeting to the next agenda, that is to hear the fifth keynote speech will be delivered by Professor Koichi Murata. And in this session, the moderator will be Dr. Muhammad Hisham from Department of Industrial Engineering, Universitas 11 Maret. To Dr. Muhammad Hisham, time is yours.
Okay. Thank you, Dr. Aditya. In this session, I will be the moderator of this session. I am Muhammad Hisham from Department of Industrial Engineering, Universitas 11 Maret. Yeah, in this session, I will moderate the keynote speech of Professor Dr. Koichi Murata. Yeah. Yeah. He will present an education program for technopreneurship, developing Kaizen mind. Yeah. Yeah, it's an interesting topic. We will listen to the presentation of Dr. Koichi Murata. I will read his short biography. Prof. Koichi Murata is the head of Operations and Production Management Laboratory and a professor at Department of Industrial Engineering and Management, College of Industrial Technology, Nihon University. He previously worked in industry as an industrial engineer at the flagship factory of Murata Manufacturing Co. Limited, which is a global leader mainly in manufacturing electronic components. His research interests include operations and production management, Kaizen, lean management, visual management, technology transfer, knowledge management, sustainable supply chain, and others. Prof. Dr. Murata takes advisory board member in international conferences and has published articles in international academic journals, such as International Journal of Production Research, Sustainability, Journal of Operation Research Society of Japan, and others. He was interviewed for NHK, Japan Broadcasting Corporation, and the Associated Press, American news agency, about future society and industry. Yeah. Yeah, we have very various value presenter in this keynote speaker in this afternoon. Okay, please welcome Prof. Koichi Murata. Yeah, thank you for your time and your and the opportunity. Yeah. Your time is 40 minutes, 30 minutes for talks and 8 minutes for question and answer. Okay, next time is yours, Prof. Koichi Murata.
Okay, I will share. Is it okay?
Yeah, it's okay.
Okay. I start the presentation. So good afternoon. My name is Koichi Murata from Nihon University, Japan. So first of all, thank you for invite as a keynote speaker in ICIMEC at 2020. Then thank you for introduction, my careers for moderator friends. So today's let's start the presentation. Today's my presentation title is education program for technopreneurship. So developing Kaizen mind for researchers and engineering. So today's content is here. Three contents. First one is background and perspectives, motivation, and so on. So second one is I illustrate program structure outline of a class. Then I'm sorry, ongoing, but last one I comment output. Main keywords is education. It is one of the main tasks of university. Then technopreneurship and the Kaizen mind. So innovation management issues, especially from R&D function to industrialization, business stage, recognized and discussed all over the world. So the value of this left side pictures and Darwinian Sea, very famous. Indicates the problem of these issues. So they help to image and understand clearly this difficulty by the expression with the pictures. So how can we overcome such difficulties? From the many literature reviews, there are various approaches to tackle with this program. So in my class, introduced in this presentation, I made an educational program to develop Kaizen mind for master program students who are the eggs of researchers and engineers. So Kaizen was a Japanese word, well known as activity, which contribute to various KPI, key performance indicator improvements at the production site in the Japanese manufacturing industries. However, in recent years, it has been widely adopted not only in the manufacturing industry, but also in other industries, public activities, and our daily life activities. So this slide, you can see, shows a recent good example of a Kaizen activities. In the first case, the Mariners, the Major League team, to which Mr. Ichiro Suzuki belonged, applied Kaizen to the motto of the last season. In an interview, Scott, Mariners managers, said that expectations as far as wins and loses, I don't have any. We have talked about it before, but can we consistently get better? So the photo on the upper right is a T-shirt with Japanese word Kaizen. So it's amazing. So Kaizen, this word consists of two Chinese characteristics. Kai, the first one, means change. Then the other one means good. So total means change good. It is very simple. So next case is here, is Angela's case. She is a very famous psychologist and the author of a great bestseller business book. She interviewed many successful people in order to find out what makes them successful. And then she described here that is after interviewing dozens and dozens of great paragons, I can tell you that they all exude Kaizen. There are no expectations. You can find Kaizen in this sentence too. When Western researchers surveyed Japanese manufacturing industries, as a result of this survey, Kaizen was called continuous improvement. So in my developed education program, I hope that master students get the ability to continue without giving up, no matter what difficulties they faced. From the next slide, the structure of the class, this class is explained. First of all, the class name is Management of Production Technologies. Then the table shows the changes in the number of students over the 3 years. So about 100 students taking class. Then it is, I'm not sure, but it is a cross measure program, cross measure program that students of 7 majors are taking. So the class consists of 2 types of programs. First one is theory on innovation management. And the second one is technology future recipe, which is a practical skill to develop a Kaizen mind. It is a 7 days program, then assigned many times to run the latter programs. Theory programs covers knowledge about innovation management. In the lecture, I provide 3 innovation management topics: innovation for society, innovation process, innovation strategies, and including 9 innovation theory. in recent years, internet education platform has been developed in which anyone can cheaply get knowledge and skills. So for this reason, designing the lecture conscious of providing a gateway entrance to getting knowledge and skills by putting a quick summary about one theory on one slide with funny time. So here is an example of one theory on one slide lecture. I'm sorry, only Japanese. So I provide one slide, simple illustrations in the class. Then in the practical programs, students will learn TFR, which is the main part of this class. So TFR is called the technology future recipe. The tool purpose is that students make the recipe to create a society, future society with their own technology. Recipe image is a cooking recipe. So simple image. So TFR consists of two kinds of tools. First one is for scene thinking as a Kaizen platform. It provides a way of how should you think to overcome your difficulty. The second one is for description methods as a Kaizen application for R&D process. It provides the concrete tools of how would you describe to realize your innovation. Learning TFR is done with 3 rhythms and 3 exchanges. The 3 rhythms are lecture, homework, and presentation for learning TFR knowledge and skills. The 3 exchanges within individual homework, teams within 1 measures, and among all measures for exchanging personal homework among all students. So from this slide, I will explain TFR in a little more detail. The first method is for scene thinking, which is a platform for Kaizen minds. The founder is Mr. Shuji Kondo, who has been management and innovation consultant for over 15 years. By drawing the 4 scenes in the upper right corner of the slide. For example, the scene of the present, you can make or think fact-finding, feeling ba, and so on. So there are 4 features of this platform. First one is realizing the creation of knowledge and value at the same time. The second one is delivering the way of thinking for continuous innovation and improvement. And the third one is easy illustration and easy making the form. And the last one is everyday thinking. Especially last one is very important point. So this slide is several cases with 4 scene thinking. It is used alone with everyone make using post-it, then writing carefully and in various forms is developed. Also, it is used in various styles of innovation activities. Here is cross-industrial exchange situations. The same here. And then here is industrial university cooperation and local community improvements at the same time. So this method is widely used until now. However, this method has one problem. It has a high degree of freedom. So various methods can be used to write each scene. So, however, my class focused on the growth of the master students who will become a researcher and engineers. So I select and provide the tools, 4 tools that correspond to innovation from R&D process. There are 4 techniques such as 100 years line, future diary, technology report, and image catalog. So for description methods, commonly 3 things such as work, homework, and viewpoint of think, and use sense. So here is a summary of 4 description methods. So in 100 years lines, master students will be asked to think about the history of a technology while using the sense of a time. In future diary, by expressing in words, master students will be asked to think about the future of society realized by their own technologies. Third one, technology reports. Master students will get the awareness of the challenges and the problems of their technology for future society that will be realized from the perspective of exchanging needs and seeds. Then last one, image catalog. Master students will use the sense of art to enhance the concrete image for the realizations. So by making 4 scenes using by the 4 methods, master students will mobilize all the intellects, emotions, and volitions of human beings to have an experience of connecting our technology to future society. Okay, so the following slide is an example of TFR output made by some students. So I'm sorry to all Japanese, but I deliver the image of a TFR. So here is the example of mechanical engineering students case. So here is 100 years lines form, and here is a future diary by language sentence. Then this is a technology report. It is a matrix diagram. So vertical line is needs axis, and horizontal line is a C's axis. So needs and C's exchange evaluations and scoring, and the output, the programs and the tasks of their technologies. Then last image is image catalog. It provides a concrete image of their technology to future societies. So in this case is mechanical engineering. TFR for his topics is composite materials. Maybe automobile topics, plastic carbon plastics topics. And then here is electrical and electric engineering issues. So TFR for communication technologies, 5 sense, viewpoint, hearing, listening. Then human being sense is improved technologies. So next is civil engineering. TFR for solar roadmap, solar road. So solar is electric energy. Solar provides electric energies, but this technology is solar systems built in the road. So always provides energies to automobile. Okay, so next case is architecture and architectural engineering. So TFR for recycled aggregate. So sustainability issues, I think. So here is a pamphlet catalog. Is these students already the concrete practical cases is done. So here is a concrete image to realized or already realized. Okay, so next one is chemical issues. So TFR for diagnostic technologies. So I'm not measures, but chemical issues. Then chemical and medical issues. So doctor is blood, get the blood, and evaluation system. So in the era now is Corona situations. I'm not sure, but this technology is a contribute to the future society. It is important technologies. So okay, so next one is this is a mathematical information engineering students. So TFR for artificial intelligence AI issues. So it is hot topics, digitalization, industry 4.10, and so on. So in my college, they master students installed challenged the development of AI to many applications. Okay, so I introduced some examples of TFR made by master programs. So then this slide is the comments from the students who take the class. So girls students comment, I thought this class was a very practical class. Then I felt that I need to be conscious of a bird's eye view for selling the product developed by my technology to customers. So master programs always focused on details problem of their technologies. So in my class, I provide bird view eyes to connect their program to future societies, I think. So boys students comment, the presentation by the students from other measures was very fresh, and it was very meaningful to be able to learn about technologies in other fields with high expectation for the futures. So this point is master students always every day spend the same the friends of same laboratory or same measures. So in the same they stay the same campus, but they don't exchange the opinions among among the other measures. So in this class, I provide the exchange opportunities among other measures. It is a key point in this class. Okay, so that's all for today's. So here is future issues in my class. So maybe detailed future issues is I have many future issues, detailed future issues. So accumulating, of course, programming implementations. So following up careers of students in the class, whether they get innovation or lose successful or not. Then this is a very detailed reviewing the teaching know-how for each method. Then this class is during 5 years. So I hope to deploy this program, this method, TFR method, to other organizations or university or other companies and so on. So that's all. Thank you very much. So here is my Instagram. So please connect and to exchange opinions and friendship. Okay, thank you very much.
Okay, thank you very much, Prof. Koichi Murata. It's very interesting presentation. Yeah, for your information, in our department, I mean in industrial engineering, we also have a course about technopreneurship, yeah, in undergraduate and also in master. Yeah.
Yes.
Yeah. Maybe we can have some lesson learned from your the practical in your department. First, yeah, I want to know whether the students study in a group or personal.
Yes.
I mean,
Yes. Hi. Yes.
yeah, in a group or in personal, in doing their task.
Yes. So in my class, I deliver first three steps in my class is consists of three steps. First one is lectures. Here's lectures for TFR, and I deliver homework. So each student study work by TFR method. Then next days he presents their homework among the same measures, within the same measures. So last 5 days to 7 days, these days, all students gathers in the same room, and one student presents this their output, total TFR output from all students of 7 measures. So 2 days to 5 days, the personal homework and the presentation among within the same measure students. Then the latter days, all students shared all homework of students. Okay.
Okay. From the audience, maybe there are some questions. Okay. Next, maybe I can. Yeah, I want to have another question. Is it possible if we have, creating groups that doing one task from multidiscipline? I mean, multidiscipline students. I mean, from various departments. If maybe we will have another form of result of their task. Yeah.
Okay, thank you for question. Good questions. So in this class, this point is not evaluate. So in this class evaluates the ability deliver to how to advance the innovation process. So it is in the Japan. I'm sort of, but Japanese style is it is people is important. People is or mind is important for innovation process too. So I deliver is how to advanced innovation with Kaizen mind. So generally business scenes. So how to evaluate the possible innovations is the number of ideas or the time of research times at the time of around the process. Then and I'm not sure about in Japan, in the R&D process, they investigate needs from the market. So the total indicates is evaluate. Then they decide a decision whether this topic of innovation process or not. So that's all. Okay.
Okay. Okay. Thank you very much. We have a question from Professor Wahidi Sudopo. I will read it. In Japan, how to evaluate the possible innovations result and result to be commercialized to the market? How to evaluate the possible innovation result or research results to be commercialized to the market?
Okay, so I already answered to, but yes, okay. In addition, finally, sales or profit is evaluation indicators, of course. Then, so we have okay, thank you. So we already, I'm not sure, but in my opinion, so we have already key performance indicator to evaluations possible innovation. So it is important to for the mind to never give up. So it is so. We provide the Kaizen mind to into the class until the egg of researchers and engineers. Okay.
Okay. Okay. Thank you very much, Prof. Koichi Murata. Very inspiring speech. Yeah. We have many lessons learned from this. Yeah. Because of the limited time, allow me to end this session. Thank you very much, Prof. Koichi Murata and all the participants. Good afternoon and have a nice day. Yeah. Thank you.
Okay, thank you very much.
And next, I will let the MC to continue the event. Please, Dr. Aditya.
Okay, thank you very much, Dr. Muhammad Hisham, for the excellent leading discussion in this keynote speech. I also would like to say thank you for excellent communication and discussion for Professor Koichi Murata. Now, we will continue to our meeting to the next agenda. We will hear the fifth as well as the final keynote speech today. Will be delivered by Professor Hyun Soo Lee from Kumho National Institute of Technology, South Korea. This keynote speech will be moderated by Professor Cucu Nur Roshidi from Department of Industrial Engineering, Universitas 11 Maret. To Professor Cucu Nur Roshidi, time is yours.
Okay, thank you, Dr. Aditya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Professor Hyun Soo Lee. Good afternoon, everyone. Distinguished guests, ladies and gentlemen. We arrive at the final session of the keynote speech for today's agenda in the 6th International Conference on Industrial Mechanical, Electrical, and Chemical Engineering, which held by the Faculty of Engineering, Universitas 11 Maret. My name is Cucut Nur Roshidi, and I serve as the moderator of this session. In the next 40 minutes, we will have Professor Yoon Lee, a prominent professor from the School of Industrial Engineering, Kumoh National Institute of Technology, South Korea. Before Professor Lee delivers his talk or his presentation, let me give you some brief CV. As you can see in the slide, Professor Yoon Lee got his PhD degree in Systems Engineering from Texas A&M University of the United States, and his major field of research interests are nonlinear control, embedded system control, stochastic optimization, deep learning, and smart manufacturing. He also has received awards such as KIIS Award and also governmental award, which both are received in 2019. He also conducted research sponsored by government and also private companies. For the government sponsors by, for example, here, Ministry of Science, ICT, and Future Planning, Korean government, and also National Research Foundation, Ministry of Education, also from Korean government, and also Korean Rail Research Institute. And for the sponsor from a private company comes from KEPCO, ENC, and also Samsung Electronics. Professor Lee also the author of one chapter in an edited book entitled Temporary Issues in System Science and Engineering, published by Wiley and IEEE Press. The title of the chapter is Design, Simulation, Dynamic Control of Large-Scale Manufacturing Process with Different Forms of Uncertainty. He also the authors of 22 journal articles in Scopus with total 200 citations from 178 articles. For today's talk, Professor Yoon Lee will deliver to us a talk with title New Trends for Smart Manufacturing in COVID-19 Era. So I read from the abstract of his talk. We will learn from Professor Lee the cyber physical system and also digital twin and automation, and also the relationship between industrial Internet of Things or IIoT and the XR technologies with smart manufacturing. He also explained to us the novel trends in deep learning frameworks. For the attendees who want to ask questions for Professor Lee, please post your questions to the Q&A feature instead of chat, and I will read your question and will be answered by Professor Lee. So, ladies and gentlemen, please welcome Professor Yoon Lee, and Professor Lee, time is yours.
Hello? Hello?
Yes.
Can you open my video? Because just the host closed my video.
Okay.
Okay.
Please, Dr. Radia, can you help Professor Lee, the committee?
Okay. Can you see my screen?
Yes.
Okay.
Clearly.
Thank you. Thank you, Rosidi. Thank you, Rosidi. Hello. This is a great honor to deliver this keynote speaking. So I'm Hyun Lee. Currently, I'm Associate Professor in School of Industrial Engineering at Kumoh National Institute of Technology, South Korea. In this speaking, as Dr. Rosidi said, we're going to discuss a new manufacturing trend in COVID-19 era. Specifically, I'm going to focus on the digital twin or cyber physical system. There are lots of definition about the smart manufacturing, digital twin, or cyber physical system. But today, I'm going to share my definition. Also, we're going to discuss what cyber physical system is. Okay. Okay. Think about it. When our ancestor remember this year, 2020, what will they call it? This is nothing but year of a pandemic or year of COVID-19. Now, I am staying in Texas for an international cooperation. However, in Texas, a daily number of new confirmed people with COVID-19 positive is over 5,000 people. Very great number. This is nothing but pandemic itself, So, what we are doing in this pandemic area, maybe these are the risks. What we are doing. For example, wearing mask, social distancing, virtual learning, offsite learning. Look at this conference. This is nothing but the virtual meeting. So this is the era of COVID-19. Very unfortunate situation. However, in manufacturing, what did we prepare and do? That's our topic of this keynote speaking. Probably several factories introduce uncontacted technology, uncontacted manufacturing technology, automation, or introduction to the sensor and some kind of thing. More specifically, the large scale manufacturing company, Samsung or LG, they try to introduce a smart manufacturing or smart factory, or the resilient manufacturing. There are many technology can be introduced to the uncontacted technology for COVID-19, the prevention. Before the discussions, I will briefly introduce my university and myself. Okay, my university is a national university in South Korea, the Gumo National Institute of Technology. Briefly, we call it, this is KIT. So KIT, located in Gumi, which is an industrial center of the South Korea. Samsung, LG, there are many other IT companies are located in Gumi. It takes 47.2% of national trade surplus in South Korea now. So KIT, my school, has been a center for supporting Korea industrialization. KIT, my school, is founded in 1980 by Korea President Jung Il-ba. Then currently we are focusing on technology and science for smart manufacturing. We cooperated with many partners in the world. So I hope this keynote or talk is one of the chances for international cooperation. If you have any inquiry for international conference, let me know using this kind of email. Okay. As Dr. Rossidi introduced, I majored virtual manufacturing in various industrial engineering field. As you know, the virtual manufacturing in industrial engineering was very popular in early 2000 to mid 2000. After that, it was unpopular comparatively. But now, this trend is completely changed due to the fourth industrial revolution. The fourth industrial revolution technology borrows the concept from the virtual manufacturing. I graduated Texas A&M in 2010. My PhD dissertation is somehow related with the virtual manufacturing and artificial intelligence, how they help each other. Also, I worked in Samsung, LG, and also I moved to KIT. Currently, I'm in charge of several governmental the governmental smart manufacturing project. And these are my smart manufacturing project with the industrial partner. the KEPCO ENC is now the builder for the nuclear power plant, and Korean Rail System is in charge of all the Korean Rail, also Osram and Samsung Electronics. With these industry partners, I am working about the smart manufacturing or preventive maintenance framework. Later, I will show the several projects about that. Okay, now we're gonna discuss the concept of cyber-physical system or digital twin and its relationship between the fourth industrial revolution. But as I mentioned, every scholar, every people, every industrial engineer has own definition about that. I don't have any intention to the answer. I just share my definition and your definition that we're gonna share and discuss. That's the objective of this keynote speaking. Okay, so I'm gonna give us some kind of example. Please think about that this example is a smart manufacturing or not, okay? Suppose that a manufacturing factory producing a handmade supercar, very luxury car, it's a handmade car. There are smart guy, there is a smart guy, and this smart guy entered the company when he was 20, age of 20. He worked very much for his company and for his family. Finally, the company's successes in the automotive industry, think about it. However, after 30 years, now his age is 50, think about it. Then now he's somewhat older. A factory manager realized that his working speed, his working ability are not the same as he was. Unfortunately, she is replaced with industrial labor, Very sad situation. This is not the automation situation. So the robot worked successfully. However, one of the automation is that the robot have the sudden defect or sudden malfunctions. So in order to detect and predict it, the company introduced Internet of Things, IoT, to detect some kind of vibration, sound, and others from the robot. When a robot has a problem, if one of the parts has a sudden sound and vibration, then it is detected by embedded IoT. Then it transmitted to some server and it analyzed. Okay. Then potential defect time is predicted or forecasted. Finally, it is prevented. Think about it, this example. Is it a good example for smart manufacturing? The answer is no. Why? Because it is just automation. It is not smart manufacturing. It is not cyber physical system. It is not digital twin. Okay. For instance, the company tried to introduce a new process, test a new process, test a new manufacturing strategy. For this manner, it is possible to check its feasibility under this automated situation? No, it is impossible because currently the factory is working in the physical world. So we cannot test with our just scenario. Instead of that, we should test something in some kind of simulated world. This is the cyber physical system. So without the virtual world, we cannot say this is the smart manufacturing world. This is just automation. So we have to distinguish just automation and smart manufacturing world. That's the objective of this keynote speaking. Okay. So it means that smart manufacturing needs an essential module, very core module. This is nothing but digital twin or cyber physical system. Okay. So the first three keywords cannot represent smart manufacturing. This is just automation. IoT is just for automation, not a smart manufacturing. Mobile control, remote control, it doesn't represent smart manufacturing. However, cyber-physical system, digital twin, simulation, big data analytics, deep learning, some kind of thing, it somehow belongs to smart manufacturing. I will explain more. Okay, somehow this kind of philosophy problem. Okay, see this picture. Do you know the man in the center? Do you know? He is nothing but Socrates. Socrates is known for his saying, I know that I know nothing. Very famous word. Okay. This picture title is The Death of Socrates by David in the 1987, painted by David. Okay. Think about that. Why do I introduce this picture in this talk? Okay. The hint is one of his hand. Look at it. One of his hand point out the sky. What does it mean? Okay. Okay. Next picture. Do you know who they are? The following picture title is Aristotle and Plato and School of Athens, painted by Raphael. I'm gonna magnify the center. Okay. Okay. The left guy, nothing but it's Plato. Also, Plato pointed at the sky with his one hand. He was the best student of Socrates. What is the common point from the both men, Socrates and Plato? They are pointing out the sky. Why? Think about that. We can find the common point from the Plato's idea. Plato's main idea is nothing but idea. Do you know the idea? What is idea? Okay. Look at this figure. What is it? Oh, most of you think, oh, it is triangle. However, it is real triangle? No. The answer is no. It is not a line, right? And the sum of the angle is not pi. Put this manner, it is not triangle. In that case, put this manner, where is the real triangle? Where is the real triangle? There is no triangle in the world, in the physical world. Only triangle exists in our brain, in our ideology. This is idea. Okay? Plato called it, this is idea. For this manner, I can say this figure is physical object or the physical factory, and real triangle is cyber object, cyber factory. Then the mapping is very important. You know, this mapping is called cyber physical framework. Okay, in real physical object, this is somehow insufficient. Okay, we cannot measure or prove. We cannot prove the sum of a triangle is pi. However, with this mapping cyber object, we can say, oh, this is just a triangle, and this is line, and sum of the angle is nothing but pi. No? Okay, do you know this guy? Yes, he's one of the greatest philosophers, the Friedrich Nietzsche. Okay, the most of you guys know the man. Then, do you know this man? Most of you may not know his name. He's nothing but Walter Benjamin. Do you know Walter Benjamin? He's known for a book name is The Work of the Art in the Age of Mechanical Reproduction. See the title, Mechanical Reproduction. It's somehow very amazing word in cyber-physical system, mechanical reproduction. Okay, very amazing word. In his book, he gives an example about Mona Lisa. Okay, you know the Mona Lisa. Mona Lisa is painted by Leonardo da Vinci. Currently, it is exhibited in the Louvre Art Museum in Paris, France. Suppose that you are in the museum and you buy a copy of the Mona Lisa with just $20 in the souvenir shop in the museum. This is the fake. This is real Mona Lisa. This is fake Mona Lisa. in the souvenir shop. Okay. However, suppose that this fake is very excellent. So it is very difficult to distinguish between the fake and the real Mona Lisa. Okay. Then we're gonna compare the real and fake, which is valuable between the real Mona Lisa and fake Mona Lisa. Most of you say, oh, real is more valuable because this is real. Okay, so but Benjamin say this is more valuable. Okay, then this real Mona Lisa has aura, A-U-R-A, aura. According to the Bart Benjamin, the real Mona Lisa has aura. Okay, this is very common word. But one of the contemporary philosophers, Jean Baudrillard, say another opinion. Another opinion. This is very important thing. It means that in this case, fake is valuable than a real. Very opposite situation. Why? Why? Can you draw a doodle or some kind of line on real Mona Lisa? No, it is impossible. However, you can draw a line, even draw some mask like that anytime, because this is fake. Okay, for me, we can imagine some kind of another creativity or have inspiration, not from the real, but from the fake. That's the Jean Baudrillard situation and his opinion. For this manner, we can say that the fake may be more valuable for more experiment. Okay, so Jean Baudrillard say this fake is simulacral, and the transition from real to fake is called simulation. This is French word. Then later, United States guy translated this word, simulation, as nothing but simulation. So this process is called simulation. We are very familiar with this word, simulation. Okay. So with the smart manufacturing concept, we can revisit this case. Okay. So what is the real Mona Lisa? Nothing but real factory. This is real factory, real Mona Lisa. And what is fake Mona Lisa? This is a digital twin. This is a cyber physical system. Then we experimented in fake because this is cyber model. After that, we prove it, and then we can check the real object. This is the power of the cyber physical system or digital twin. So smart manufacturing's essential module, core module, is nothing but the cyber physical system. Then some company call this is the digital twin. Okay. Now you know that the current age is the age of the post-industrial revolution. It is suggested by Klaus Schwab, a former Swiss economist, now a UN officer. Okay. For Industry 4.0, United Nations organized the 5 working groups. These are the representative working groups. The most working groups are related with the smart factory, real environment, and human beings and work. It is some kind of a mapping between real world and virtual world. Okay. Okay, then now we have to understand why cyber physical system is needed. In order to implement it, we have this checklist. First, how can you make a digital twin? How can you make a cyber system? The prompt. the physical world. And second, how can you interconnect both systems, between physical system and digital system, digital twin. Then how can you develop a physical system? Because this is a final target, okay? So think about that. We have many manufacturing strategy, manufacturing scenario, okay? So we construct a virtual world. This is a digital world. And we test, we simulate in the virtual world. And probably, and we just transit to physical system. That's some kind of a cycle in the smart manufacturing. Okay. Also, we are human, so we have to consider the human being and relationship in this system. Okay. So, put this manner, what is the role of industrial IoT or IIoT? Okay. So, IIoT is not just a tool for just sensing and transmitting data. Okay, as precious role is nothing but interconnection between digital twin and physical system. Okay, so whenever I deliver this kind of talk, so I got this question frequently. Okay, the CAE or computer-aided engineering tool or simulation tool, it can be a digital twin, can be the virtual software. The answer is no. Why? Because they don't have any intention or real update from the physical world. There is no intention. There is no real update. Just one transition, okay? Then construct simulation model, that's it. Okay? There's no the real interface. Okay? What is the real interface? This is made by IIoT or IoT. If a simulation tool, CAE tool, has this kind of real protocol, we can say, oh, this is a cyber physical system protocol. Okay. So, for this manner, several software companies developed many digital twin tools. The Elastic Beanstalk, okay, made by Amazon. And this is open source, OpenStar, made by Python Society. And IBM provide the Bluemix, and General Electric provide the Predix, and Siemens is made MindSphere. There are many CPS or digital twin tool. Okay. However, there are several issues in these digital twin tools. First one, they are so expensive. Usually their price is over $1 million. They're too expensive. It's too difficult to also customize it. They're too difficult. And they don't have any suitable deep learning modeler because so we have to simulate something. The simulation tool is working using deep learning currently. However, this tool doesn't have the current the deep learning modeler. Okay, for this matter, a number of companies have difficulty in introducing cyber physical system tool. That's the problem. The one example is about the Predix. Okay, so Predix is the General Electric's digital twin platform. So they use Apache server, they use MySQL. However, the software is too dependent on General Electric tools and also very difficult to customize. Okay, there are many pros and cons. Okay, so from now, we will check the effect of the smart manufacturing. In 2017, Capgemini, one of the best consulting firms, surveyed the effect of smart manufacturing. According to smart manufacturing, according to Capgemini, smart manufacturing has 7 times productivity than a traditional factory. Also, in quality, smart manufacturing's quality is 12 times higher than a traditional factory has. This graph shows average productivity and quality gains from smart manufacturing so far. In productivity, smart manufacturing has over 17 productivity gain. Similarly, the smart factory has over 15% quality gain. So we had better introduce smart manufacturing in this COVID-19 era. Currently, many companies in various manufacturing domains try to introduce smart manufacturing technology. This is the one framework made by the Capgemini in 2017. See, the essential module is digital twin. For example, remote monitoring, autonomous operation is not important. Okay, predictive maintenance is not important. This is just automation. Okay, AR, VR is not important. The most important thing is digital twin. So from the physical factory, we have to construct the first digital twin. Okay, then we apply the manufacturing scenario or strategy, various strategy, and the digital twin. Okay, that's the essential module. Now, I will show my fast and ongoing smart manufacturing project briefly. The first example is a smart factory for a defense industry. So I implemented a smart manufacturing platform for producing a missile. It's a Korean missile. In particular, our focused process is a surface-mounted technology, SMT process for missile electronics. Okay. So the middle figure, that shows the SMT process handling the missile electronics. We mimic it and created some virtual world. Okay, this is a physical world, and this is a virtual model. Okay, so our target is to keep unprocessed quality. Okay, we measure and keep the unprocessed quality with the good level. Okay, to measure, we analyze each device and processes, and insert IIoT, sensor, other processors. Okay. So the used processor is Intel's Edison Atom processor. It is used for the basic IIoT, IIoT core processor. Okay. So we installed several sensor to detect the needed quality level and process indices, KPIs. The IIoT measures data and transmits it to the data lake server. Currently, my virtual factory located in this data lake. Also, we used the POG computing technology for direct control using Cisco POG computing technology. Not just cloud computing, it's POG computing. I will show the small demonstration for it. Okay, so this is an SMT processor. This virtual model is linked to the real model. Okay, so each device has some kind of IIoT and some kind of sensor. And then the time, the quality is measured. Okay, if it has some problem, so it is detected in the virtual world first. And then we can simulate something. Finally, this result goes to the physical world. Okay. Also, we can change some kind of manufacturing parameter. This is some kind of a simulation model also. Okay. Okay. The second project is related with the XR technology. XR indicate an integrated reality technology with virtual reality, augmented reality, and mixed reality. In particular, mixed reality is bidirectional technology between a human operator and VR AR object. Okay. Ten years ago, a traditional virtual manufacturing technology used interface graph. Okay, in this figure, a robot picks a workpiece from a conveyor and then put another conveyor. This interaction is captured using this interaction network, interaction graph. Okay, and this information is used for following control. Okay, this is the typical interaction graph for this typical manufacturing cell. This is work cell. However, it is very limited in the large scale manufacturing environment because our target physical factory is some kind of large scale. So in this some kind of very limited interaction, we cannot capture. Okay, in digital twin, this interaction modeling is very important. So we have to introduce another technique. This is nothing but neural network or the deep learning. Okay, so using deep learning, we created this kind of interaction autonomously. Okay, that's the role of the deep learning in virtual model and digital twin. To do it, okay, so we use the IIoT device. Each IIoT device captures interaction and relevant information. Then this captures the data and analyzed in the digital twin. Several classification, artificial intelligence, or deep learning technique applied. Then finally, we created some kind of rule. This is some analogy. Okay. Then it is layered into 4 layers. Okay, virtual space layer, mapping layer, library layer, ontology layer. So we call this is a metaverse. This is nothing but a new type of digital twin framework. Okay, so in metaverse, the virtual object located in virtual space layer. Then its information, its meaning is located in ontology layer. Then library layer connect a common model protocol. Then mapping layer connect each node using deep learning. Okay. Here is the example of the metaverse. Okay. Finally, a large-scale factory can be represented using this metaverse. Okay. We call it, this is a new type of digital twin. Then this is a digital twin construction cycle using metaverse. Okay, there are many large-scale factory. Okay, then using deep learning, we capture some kind of interaction. We use also IIoT. Then finally, it is converted to metaverse. Then knowledge can be captured, extracted. Okay, so we applied this model to AR/MR application. Okay, this factory is airplane engine producing factory. This is airplane engine. So using AR environment and metaverse model, my team, they created a digital twin. That's a digital twin. Okay, and this digital twin, we can test the different process manufacturing scenario. Okay, so we use the self-organized map and the neural lab for extracting the process interaction and information. This interaction graph is converted to pattern model, also stochastic network. Then using some kind of change that we can test. These are some snapshots we developed. Okay. One of also my research team applied this to another manufacturing factory, airplane production. Okay. One of my project is to establish digital twin for a nuclear power plant. As you know, the human's operation and their checks are very crucial for operating a nuclear power plant. But existing framework, existing model doesn't consider dynamic human model and behaviors. In order to overcome the issue, we create a new digital twin model controlling the power plant. So with this digital twin model, so we check the field of view of a human, considering different physical size and configuration. Also, we change the nuclear power plant layout and evaluate them. Okay, so these are the several lists which I have run in several smart manufacturing projects. For example, the manufacturing strategy, they should be tested in the digital twin. Also, the connection with the physical plant and cyber plant is very important. However, also we have to consider human. Okay, this kind of thing is a lesson learned. Then I'm gonna briefly introduce the deep learning trend. In 2016, when I started the smart manufacturing project, the deep learning method just classified into the general deep learning or the deep belief net. This is first deep learning at the time. Then now the convolution neural network and generative adversarial network and RNN and deep reinforcement learning have been introduced. Currently, the neural OD, transport, transitional learning, hybrid deep learning, a new trend in deep learning. Okay. This is one of my paper using multimodal Gaussian Bernoulli RBM based DBM. In my digital twin project, I proposed this model to control continuous real value input. Okay, many factory can be controlled using the real value. Okay, so in this framework, so we can control it. Then I applied the DNA analytics into Osram car head-right manufacturing process. As you know, some kind of car manufacturing, they need a multi-site manufacturing process. In order to detect abnormal manufacturing signal situation, large-scale digital twin and cloud environment has been introduced. Okay, so I used the analytics using DNA. One of my questions frequently I have is how to handle shortage of data. If a manufacturing situation or manufacturing situation, sorry, if a manufacturing situation or detector lag, so how can we do? In this case, we have to generate more data where nothing but the virtual world. So in this case, virtual model or digital twin is just to generate our needed data. We call this is the virtual data. Okay. So I applied a preventive maintenance framework for detecting a car defect. In case of lack of defect car, okay, I applied the generative adversarial network successfully. I generated many data in the virtual world, and then it detected defect of car. Okay. Okay. So these are my end of presentation. So in this case, so I'm gonna deliver the key module of the smart manufacturing is nothing but CPS digital twin, and we have to simulate it in the digital twin. And lot of the IoT is nothing but connection between the physical factory and digital twin. And also I introduced a new digital factory model, metaverse. Then we have to construct the virtual data. Data is generated in the digital twin. Okay. I hope this talk gives some insight for your smart manufacturing concept. If you have a question, let me know. Thank you very much.
Okay, thank you very much, Professor Lee. It is very insightful presentation, and I think it open or gives a new perspectives about what we call CPS. So there is one question from the attendee. This is from Andri. He is from SKF, a large bearing manufacturer. The question is, in the predictive maintenance project for railway system, what kind of parts in the term of rotating parts you monitor and how? And for X wheel monitoring, how do you figure correlation between bearing condition and rail track? Something there is a sharp turn.
Okay, a very good question. So in Korean railway system, and there are many, the rail system, they have some kind of system. This is called TCMS, the Train Control Management System. TCMS measure many sensor signal and many signal from the each train part in real time. So it includes some kind of the bearing condition and rail track condition and some kind of thing. There are many huge data, okay? Then the X input is this kind of TCMS data, and Y input is the defect history. Then using the deep learning, so we mapping this kind of relationship. So this is the basically predictive maintenance framework. Then one of the problem is that we don't have enough data. So we created, as I mentioned, we created some kind of the virtual train model. Then we generated defect. Okay. Finally, we have mapping. That's some kind of railway system. Okay. Okay, that's it.
Okay. Thank you, Professor Lee, for your answer. I hope it answered the questions. I have two questions for you, Professor Lee. For the first one, we know that the pandemic, the COVID-19 affected mostly in the small medium enterprise, mainly in Indonesia. I don't know this condition whether also happen in Korea. How the SME implement the CPS, or maybe you can give some opinion about how the SME adopt the CPS. And the second one is about the last explanation about the monitoring of car defect. Is it real time or static? I mean that we can monitor the defect real time using maybe video, or we can do it in the static status using a still photograph. So this is the question, and also some other questions, but maybe you can answer my question first.
Okay, very good question. As I mentioned, the smart manufacturing is not related with automation. So there are some kind of SME, the small medium company, small medium enterprise. They don't have money. They don't have enough money. So they don't have fund for introduce automation. Instead of that, just think about virtual world. The virtual world is somehow very small model. It's not related with somehow the automation. We started just from this very small model, and then we grow this small model. That's the starting point of the smart manufacturing. So this is somehow the very beginning good point of smart manufacturing in SME. And the second question, I don't know exactly. This is somehow it's based on the situation. Maybe the real-time connection is possible using IIoT and something. However, it's very difficult, especially in the SME. So in this case, we just started from very small model, even though it has many flaws, okay, many defects. So we started and just we grow gradually. That's my strategy. And this is my consulting strategy for SME or some kind of thing. I don't know exactly. Okay. Thank you.
Sorry to interrupt, Prof. Lee. Okay, I have one quick question here. Can you hear me?
Yeah.
Okay, what is the difference between computer integrated manufacturing and this CPS or smart manufacturing? What make this so different? And is this an advancement of computer integrated manufacturing? So-called cyber physical system, something like that. Do you have any comment on that?
There are many definition. There's no answer about that. However, I think computer integrated manufacturing is very big word. Okay, very big word. And the small set is type of physical system. I think in now the post-industrial revolution, very small set, new concept appear. This is the digital world. This is the cyber physical system. Some of the computer system, computer integrated system, CIM, is much bigger, I think, but it's not answer. Okay, I don't know.
Okay, Professor Lee, we have 2 more questions. The first is from Sudiptia Titio Coin from Polytechnic Admi Surakarta. I will ask question. In my country, Indonesia, has tropical season with high humidity. It can bad effect with digital system. How do you reduce this bad effect to digital system? You may answer the first question and I will continue the second question after your answer.
Okay, about humidity is also the forever problem in factory, because the factory situation is not so good. So in that case, we just create a mapping. So even though this is very humid situation, so the sensor measure, but this measuring data is not accurate due to the humidity or some kind of weather condition. But we can interpret it using some kind of intention or some kind of logic. Even though this is very bad situation, so there are some kind of the mapping function. So this the better signal goes to the mapping function, and we generated much better data. Some kind of, we have to find this mapping function. Okay, that's a lot of the our industrial engineering role. I think that's the lot of the manufacturing. Okay, I don't know exactly.
Okay, thank you. And okay, thank you. And therefore, the last question comes from Adnan Hassan, University Technology Malaysia. Thank you for an interesting talk, Professor Lee. Can you give some comments on cybersecurity issues with respect to the digital twin?
As you know, cyber physical system is very important and core module, because we have to do many crucial manufacturing strategy and the cyber physical system. So cyber security is very important. So I don't know exact key technology about the cyber security, because I'm an industrial engineer. Okay. However, it should be checked more carefully about security, because the cyber physical system is somehow the strategy. So very great test bed for the future manufacturing test bed in the factory. Okay.
Okay. Thank you, Professor Lee. I think the time is up.
Thank you, Rosadi.
Thank you. Thank you, Professor Yunsun Lee, for your insightful, inspiring, interesting, and also important speech. And thank you also for the attendee for the active discussions. And see you on the next Icimece next year. And I conclude this session. And I return the time back to Dr. Aditya. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Cucu Nur Roshidi, for leading this keynote speech. I also would like to convey my best regards to Professor Hyun Soo Lee, who already spared his time. I think now is more than 2 a.m. in Texas. Thank you, Professor, for your time. Now we are entering final agenda of this conference, that is to hear award announcements for respective disciplines in this conference. It is Icimece and Symposium of Structural Integrity. This session will be delivered by Chairman of Icimece 2020, which also provides a closing speech for this event. For Dr. Dominicus Donadona, time is yours.
Okay, thank you for the time. Good afternoon, ladies and gentlemen. We have come to the end of today's conference. On this occasion, I would like to announce the best paper for each category in ICIMEC 2020. There are 7 papers as follows. The first category is industrial engineering. The best paper in industrial engineering is the title Development of an Electronic Reverse Logistic Network Model, a literature review. The others are T.P. Sari and A. Masruro, AMS ASI, in collaboration with of Department of Mechanical and Industrial Engineering, Universitas Gadjah Mada. Okay, the next category is from mechanical engineering. The title of the best paper is Modeling of Droplet Coalescence using Radial Basis Function Method. The others are Eka Prasetya Budiana, Pranowo, and Dominicus Donadono Dwivia Cahyana. Collaboration of Department of Mechanical Engineering, Universitas 11 Maret Indonesia, and Department of Informatics, Universitas Atma Jaya Yogyakarta, Indonesia. The next category is from chemical engineering. The title of the best paper is Integral Composite Membrane, Effect of Different Concentration Polyphenol Alcohol on the Membrane and its Performance Toward Fouling and Mercury Removal. The others are N.Z.K. Sari, L.H. Rosli, and M.F. Basri from Department of Chemical and Process University Technology Mara, Malaysia. The fourth category is electrical engineering. The best paper is design and implementation of hybrid filter for harmonic reduction and dump resonances in nonlinear roads. The others are YC Arif, LPS Raharja, and S. Aulada from the Department of Electrical Engineering, Politeknik Elektronika Negeri Surabaya, Indonesia. Next, from the Special Symposium in Engineering Structures, the best paper is Free Vibration Analysis of Interfacial Deponent Sandwich of Ferry Roro Stearns Ram Door. The authors are Tuswan, Ahmad Subaidi, Bambang Isesa, Abdi Ismail, Muhammad Fatih Ilham, collaboration of Department of Naval Architecture and Department of Civil Engineering, Institute Teknologi 10 November, Surabaya. The next category is also still a special symposium for the material and general engineering. The title is Improvement of Auto Checking Harness Machine using several material series of aluminum structural frame. Case study on Mitutoyo HR522 harness tester. The others are Bernardus Placenta Previous Kaisar, Iwan Istanto, Pandu Sandi Pratama, Jong Yung Cho, and Aditya Rio Prabowo. Collaboration of Department of Mechanical Engineering, Universitas 11 Maret Surakarta, Agency for the Assessment and Application of Technology, or BPPT, Jakarta, Cobot Company, Industry Research Building Room from Dong-A University, Busan, South Korea, and Department of Industrial Design, Pukyong National University, Busan, South Korea. The last category is from Pembangkit Jawa Bali, or PGP Connect. The title of the best paper is Repair of Cracked 150 megawatts high pressure steam turbine rotor coupling. The authors are Andrianto Hapsoro, Happy Hanipa, Kirill Grepinik, collaboration of PT Sulser Indonesia from Kawasan Industri Kota Indah, Kota Bukit Indah, Purwakarta, Indonesia, and Sulser Turbo Services, Houston Incorporated, Houston, USA. To all of the others of the best papers, congratulations. Last but not least, I also want to thank for all of the keynote speakers, invited speakers, all of the participants of Icimece 2020, and also the organizing committee of Icimece 2020. Special thanks to PGP Connect, the co-host of the Icimece 2020. The conference could not succeed without you all. In the future, I hope we will meet again and collaborate in much better situation. Thank you.
Okay, thank you very much for Dr. Dominicus Danardono for the award announcement and closing speech. Congratulations for the selected papers and the best papers. With this, all the programs of the 6th Icimece 2020 have been completed. I thank you very much, especially guests, keynotes, and participants for your kind attendance and active engagement in this event. See you in the 7th Icimece 2021. Good afternoon. Thank you very much.